Hello and welcome to the EcoCast. Today's topic is monitoring and optimizing the IT environment, applications, and the cloud. The EcoCast is brought to you by Actual Tech Media, and on today's event, you'll hear from experts at Solarwinds, Red Hat, Gitlab, Rapid7, Nutanix, and Progress. We've got a really cool event lined up for you today. This is a hot topic, monitoring and optimizing applications across the hybrid cloud, public cloud, on-premises. Thank you so much for joining us on today's event. Before we jump into it, just a few things that you should know about the EcoCast. We at Actual Tech Media created the EcoCast, MegaCast, and Summit event series to help educate IT professionals such as yourselves about the latest and greatest in enterprise technology to help you do it quickly and efficiently from the comfort of your home or home office and to get all your questions answered. We want to help you to solve your IT challenges. And you also have a chance during that process to win some valuable prizes. So again, thank you so much for joining us. Before we kick it off, just a few things that you should know about the event. We want you, as I said, to get your questions answered. So I encourage you to use the questions box. It's there on the left-hand side of your audience console, and I can draw your attention to it that way. Of course, I appreciate all the good morning and hello messages from across the United States and also around the world. But we want your technical questions on today's topic because I'll be doing dedicated Q&A sessions with each of the presenters on the event. So keep those technical questions coming. We also encourage socialization of the event. You can use the Twitter icon on the bottom of your screen. The hashtag for today's event will be automatically appended, which is ATM EcoCast, and I'll be monitoring Twitter throughout the event, so thank you in advance. We also have a number of resources there in the Handouts tab on the left-hand side of your audience console. In the Handouts tab, you'll find links recommended by today's expert presenters, as well as a couple of PDF assets as well. So make sure that you check those out before you leave the event because they won't be readily accessible after the presentation. And finally, prizes. As I mentioned, we've got some cool prizes on today's event. We've got 3 Amazon $500 gift cards. You must be live in attendance to qualify for the drawings, and there are a number of other prize terms and conditions that you should know about, including all prize winners must submit an IRS Form W-9 to Actual Tech Media. We will reach out to prize winners after the event. Now, Actual Tech Media has partnered with the Gorilla Guide Book Club to support the charities you see on the screen there, the Diane Fossey Gorilla Fund and One Tree Planted. We encourage you to check out gorilla.guide, where you can download free educational ebooks. There's a multitude of topics there around enterprise IT. They're all completely free, so make sure that you check those out. As I mentioned, the hashtag for today's event is ATM EcoCast. You can follow Actual Tech Media on Twitter using the Twitter icon on the top right-hand corner of your console there, as well as me, David M. Davis. So I hope to socialize with you on Twitter later or during the event. You can also subscribe to all the Actual Tech Media channels on YouTube, Facebook, and the 10 on Tech podcast. You can find that in the iTunes store. Of course, we post all of our latest and greatest content on LinkedIn. That seems like the hot place to socialize enterprise technology content these days, so make sure that you follow Actual Tech Media there. Again, the social icon for LinkedIn is on the top right-hand side of your audience console. And with that, I'm excited to kick off a special keynote introduction here. We're excited to have and hear again from Mr. Ned Bellavance. Ned is a Microsoft Cloud MVP. He's a Pluralsight author around numerous pieces of content related to, I know, specifically Azure and many of the HashiCorp products. He's a podcaster, blogger. You can find him vlogging over on YouTube. Find him on Twitter. He is Ned1313. And he has a special presentation here prepared for us on the topic of monitoring and optimizing the IT environment, applications, and the cloud. So with that, take it away, Ned.
Bellavance, Ned1313 on Twitter, and I am coming at you with 4 key considerations when you're implementing application monitoring for the hybrid cloud. Now, we all kind of know this is a thing that's looming over the horizon. If you're not there already, you're probably already working with a hybrid cloud environment. So how does that impact your monitoring strategy? I've got 4 key considerations for you. Number 1, you need to assess your applications before you migrate them. I know it sounds crazy, but hold on, I'll explain. See, the whole point of hybrid is that some of your applications are going to live on premises and some are going to make that great migration up to the cloud. But how do you decide which ones are going to do that? Your monitoring system should be able to give you a lot of the data points to determine if it's a good fit to migrate in the first place and if it has dependencies on other applications that would prevent it from being a migration candidate. Your data center is not going away. Make sure the applications you move are the right ones. So that's one consideration. The second consideration is, can you have consistent monitoring and tool sets in both the public cloud and your on-premises environment? The monitoring systems that you're using today, well, you've probably been using them for a while, and they're really good at monitoring what you have on premises. They're probably good at looking at hardware systems. They're probably tuned to your VMware environment, but are they able to monitor applications that have been moved to Microsoft Azure or AWS? I don't know. Hopefully they are. But if not, you have to consider, do you want to invest in a new monitoring solution that's native to one of those clouds, or select a third-party monitoring solution that will allow you to monitor across the entire spectrum of where your applications are living? That's pretty important. The third key consideration is baselining and anomaly detection. Remember those applications that you moved up to the cloud? Well, hopefully you got a good baseline of how they're acting now that they're up in the cloud. And honestly, you're going to have access to different information when you make that migration. Some of the low-level stuff, like access to what's going on in the hypervisor, well, you don't have that anymore, but you do have access to a whole new rich number of different sources for information about what's going on with that application. Hopefully your monitoring solution can effectively baseline that information and then detect anomalies when they happen, because no matter how much work you put into architecting that application and figuring out exactly its sizing, you're going to need to make tweaks and tunes later on in the life cycle of that app. Which brings me to my 4th point, which is dynamic feedback and automation. If you've got everything tuned up real well and your application is humming along, that's great, but things are going to change. Unforeseen circumstances are going to happen. And ideally, your monitoring solution not only provides dynamic feedback to those who are doing the monitoring, but it can also hook into an automation solution that can help remediate issues before someone needs to get paged at 3 a.m. to add more space to the database because you forgot about that Black Friday sale that's going on. So those are my 4 key considerations for monitoring in hybrid cloud. The first one is assessing your application. The second is consistent monitoring. The third is baselining and anomaly detection. And finally, dynamic feedback and automation. That's all I have for today. Thank you so much for watching. I'm going to hand it back to David. If you want to find me, I'm Ned Bellavance, and you can find me on Twitter at Ned1313. Be sure to reach out and say hi. Thanks.
Excellent presentation there. Thank you so much, Ned. Really always enjoy your advice and content. So again, you can follow Ned over on Twitter or on YouTube. I've just brought up a poll question for everyone out there in the audience. The question is, what's your time frame for adding new or updating existing IT solutions at your company? Specifically, we're talking about monitoring and optimizing solutions that we are learning about on today's EcoCast. So I'll give you a few moments to answer that poll question, and then here in just a moment, I'll be introducing you to our first presenters. All right, thank you everyone who responded to that poll question. We do appreciate it. Periodically throughout the event, we'll have a number of other polls that we'll be bringing up. So of course, we appreciate your participation in advance. All right, thank you everyone for responding to the poll question. Also, thank you to everyone out there who posted all the great questions and all the good morning and hello messages out there. I see Pedro, Ron, Tim, Mario. All right, Joseph, Julio. Lots of great comments from around the world. Thank you so much. We really appreciate our audience. And with that, I'm excited now to introduce you to our first two presenters on today's EcoCast. Welcome, Mr. Jared Hensel, Senior Product Marketing Manager at Solarwinds, and Mr. Pete DiStefano, Principal Product Marketing Manager, also at Solarwinds. Jared and Pete, are you there?
Yes, sir.
Excellent. Thank you both for being on. Take it away.
Great. Appreciate everyone's time. Looking forward to sharing some good stuff with you today. As was mentioned, my name's Pete DiStefano. I'm with Solarwinds, and I am a product marketing manager for a couple of our infrastructure and application products. And Jared Hensel is my partner in crime today, and he specializes in our marketing for our database products. So real quickly, for those of you who don't know who Solarwinds is, I'm going to just spend a couple of seconds talking about the portfolio and kind of putting in the context of what we're talking about today. Then we're going to get right into it. We're going to talk a little bit about application and database-centric monitoring, what the differences are, and then, where's the value of bringing both of those things together to really optimizing the health and performance of your entire application stack. Then we're going to stop talking, and we're going to actually show you these products and how they can apply these concepts I just mentioned between application-centric and database-centric monitoring. So let's get right into it real quickly here. Solarwinds got like 50 to maybe 60 products, and we've done a good job of trying to make it easy to explain, well, what do we do? Well, for IT professionals, we do everything from helping them manage and monitor their network, infrastructure, database, applications. We have service management offerings, IT security, and it doesn't matter who you are. If you're an IT professional, and you could be a developer, you could be operations, you could be a monitoring engineer, you can be a DBA, you can be a manager, and whether it's on-prem, private cloud, public cloud. So the products we represent really cover the gamut in IT, as you see here. And today we'll probably be covering 2 or 3 of what we call these pillars, from the infrastructure, the database, and the application. And today we're going to focus on 2 products. I'm going to take a moment here to just take you through AppOptics. So Solarwinds AppOptics, it is a full stack application performance monitoring tool. And from the infrastructure, and it's integrated. So your infrastructure application, and whether you're monitoring your physical servers, virtual hosts, your containers, whether you're using Dockers and Kubernetes, whether you're in a server or serverless environment, AppOptics can do that. And then connected and in context with the application, we can do everything from helping you understand application performance, application trends, and one of the real superior powers that AppOptics brings to the table is the capability to troubleshoot and start at the very highest level, figure out what's going on, especially with modern applications like microservices-based applications where applications broken into multiple modules. And those modules can be running in multiple places, multiple clouds, partly on-prem, and being able to troubleshoot that application, look at the specific transactions that make up those applications. And we have the capability to drill down. But before you do that, because we want to make this easier and easier, and AppOptics is applicable to multiple people across IT organizations, we've provided some root cause summaries. So we tell you, hey, here's where this application is slow. Here's where you really need to look to remediate if there's a problem. To the point, we also let you go and drill down deep, all the way down to the line of code, figure out what's going on. So very powerful product, designed for modern applications, but works in an on-prem world as well as a cloud environment and a hybrid environment, and really focuses, as I mentioned, it's application-centric and provides you the capabilities, whether it's just monitoring the health, drilling down, troubleshooting, and getting to the root cause of an application problem. Jared?
Thanks, Pete. So yeah, I'm going to talk about Database Performance Monitor, formerly known as Vivid Cortex. What this product is we already had another database product at SolarWinds, Database Performance Analyzer, which is more on-premises and getting you into the actual query and optimizing it, where this is a SaaS-based solution. DPAM is a SaaS-based tool, and basically it's designed to work at scale. It's designed to basically work in conjunction with APM solutions out there. It's going to monitor your open source databases, so your MySQL, Postgres, Mongo, etc. But what's really good about this is that it's showing you how it's working with your application. You're able to take the queries from an APM, pull it in here, and start searching on there. It's going to give you visibility into your resource health. It's going to give you your golden signals that Google likes to lay out, your latency and throughput and concurrency and all of those things. So it really is going to help you tune and optimize and look at your application from a database point of view. All too often we have, finger pointing between organizations. It's the network, it's the database, it's the app, it's whatever. But you're only looking at it from one point of view. This is giving you that opposite application view from your database. So is your database getting hit by multiple applications? Is it doing a backup? Is it on one server? Is it on 5 servers? All of those things that, an APM is going to say, hey, it's a database, but that's really where I kind of stop on saying on my troubleshooting. This is going to flip that and go, yes, it's the database, but that's because you're running a GL report at the same time you're trying to process an order or whatever it is. So it really gives you a good insight into there, allowing you to ship code faster, see if code is impacting anything, allowing you to reclaim resources, because, again, you go to the cloud or virtualize a server or anything along those lines, you're going to kind of swag out what you think it needs. And this is going to give you that clean ability to say, hey, you've got a ton of CPU you're throwing away or a ton of memory. You probably need to right size your instance or your VM with Azure or AWS or Google or whatever it is. You can tier down and get similar, if not the same performance. So again, really allowing, the IT professional and IT organizations to ensure that they're getting the best bang for their buck, and addressing deficiencies that may need to be, hey, I need more memory, I need more IOPS, whatever it is, that you're just not kind of throwing the kitchen sink at it. So with that said, I'm going to let Pete start his demo on the application side, and then we'll funnel it into the database side and kind of show how they, work together and come together. Oh, actually, you know what? I have one more slide to talk about. And kind of, as I was talking about earlier before Pete gets into his demo, was that, this is where the two come together, is that, all too often your APM is going to say, it's the database. It took 15 seconds, 5 minutes, whatever it is, to give me back that query. But I have no concept of what that query did, why it did it, what else was going on that box. Was it because I had one request, or I had 5 million requests all at the same time? So again, looking at it from that different lens allows you to have that cohesive picture of, hey, I've troubleshot the code, I've troubleshot the response time, and now I think it's in the database. Let me take a look, or flip it going, yes, there's a database issue, but it's because you're asking 1 million things in 1 second. It's the database, but really, is there a better way to write this code so I'm not just getting hammered to do all these things simultaneously? So having that combined feature set really gives your IT organization that complete picture that they need to troubleshoot. Now, with that said, I will let Pete get into his demo of AppOptics.
All righty, give me a second here. Can everyone see my screen?
That would help. All right, I see.
Okay. Sorry for being technology challenged. Anyway, as I was mentioning with Apache, the integration between, there's integrated infrastructure and application services. You can see here there's a bunch of services. These are applications. And then you've got your hosts, whether it's physical, virtual, and your dashboarding. So I'm going to take it, first of all, I'm just going to show you, the minute you install a plugin or an integration, you get a out-of-the-box dashboard, pre-populated, and it starts collecting metrics. And then you can create custom dashboards. Again, you can take existing dashboards, modify them, clone them. This is just one example of one of the dashboards. And some people get excited because apparently some people like this dark theme, light theme, anyway. But these dashboards are real-time, interactive, and like I said, very customizable. But let's kind of get into the product. So this is the infrastructure tab, and what you're seeing here is just a list of physical, virtual hosts. I actually have a capability to make that into a map. I'm sorry, guys. I don't know what is going on with my system today. But if you see here, and I click on region, I can sort by region. I can also sort, in this case, I'm going to sort by the services. And I've actually, this is CPU utilization, but I can color code so I can know right away if something's red that I need to drill into it. Well, in this case, I'm going to drill into one of the hosts. And as you would expect, it's pretty clear. You've got CPU, memory, disk, network. If you see here also, you've got all of the services that are running on that host, all of the processes they're running and how they're taking up CPU. So lots of great data. You can very easily just click on any of these and create your own dashboard right from this. You can set up alerts for any of these metrics and manage them from an infrastructure perspective. Now let me take you over to the services view. Again, same thing, there's a list view. And by the way, these are all microservice modules that make up a booking application. Okay, so whether this was a single application or multiple services, you see here you got this web tier. Well, what I'm going to do, I also have the capability, instead of a list, have a map. And you'll see here with the map, you not only have all these services, but you can see the dependencies they have. You also can see they're color-coded. So I'm seeing right here, wow, those web tier I was talking about is red. I can drill right into that, and it's going to immediately tell me what it's immediately interacting with, and it's sharing me error rates, requests, etc. And from here, I can drill into the service details. Now, what's cool about this is a little bit new. This is one of those summaries that tells you what's going on. So you don't have to be an expert. You don't have to be intimate with the infrastructure of the application. It's saying right here, hey, the following host is seeing a high request volume compared to the rest in the service for that host. It's saying most of the time it's being spent on remote calls to the booking service. And I've got all of these great metrics here, the key, what they call golden signals, response time, requests, errors, CPU utilization. I can compare it to a month ago, so I can quickly see, is this an anomaly or is this something that's happening on a regular basis? But I want to go one more step. So I'm going to click on the trace, and I want to drill into a specific trace. So what I'm going to do here for that web tier, I've got this kind of heat map. I'm going to call out one of these outliers. And that's the one I want to click on, and it's saying to me, wow, this transaction took 7.88 seconds. 99% of it was remote calls. Shows me the 3 errors of what's going on. So like right away, I've got a good sign of what's going on. Now, if you want to drill deeper, you can. But before I do that, let me give an example that's kind of more appropriate for this call. Here's an example. It says, we had a trace that took almost 2 seconds, 91% of the time database calls. And it's going to show you the query, how much time, how many requests, how many calls, how much time it took. So clearly the thing that slowed this transaction down, okay, was the database. So now I'm drilling into the details of that transaction, and you see, wow, almost 5 seconds of a 6-second transaction was the database. But was the database the cause of the problem? Was the way they designed the application to make all these calls the issue? And that's where you want to go further. So one last thing I'll do before I'll pass it over into the database-centric view is, in addition to getting this level of detail, and by the way, I can drill into any one of these services that made up that transaction and get exactly what details were going on, right down to looking at code. The other thing I can do is I'm going to click on this search logs button, and what it's doing is saving a ton of time, because for every one of those services that's creating a log line, what this is doing, this is going into a log, one of our log products, Logly, and what it did was it appended a trace ID to every log line associated with that transaction. So now I don't have to search anything, and what I have here is all of the log lines associated with that transaction. Now again, from an application perspective, I've narrowed it down to, okay, here's where it's taking the most time. My guess is Jared could probably help you figure out, okay, is it really the database or are there some other issues? So Jared, why don't you take it over and share how DPM now might take this in another direction from a database-centric point of view.
Thanks, Pete. I think you have to stop sharing first for me to take over sharing.
All right. And I just stopped sharing.
Boom, share my screen. Here we go. We're going to go with screen number 2. Allow. All right.
Perfect.
Is it sharing right now? Can you see it?
Yeah, looks good.
Okay, great. So right now, I log right into the summary screen at DPM, and immediately you can see this is completely customizable. So I'll be honest, the demo people changed this within the last 48 hours. Didn't look like this on Friday. But right now, we've plotted CloudWatch statistics across the top. So if most people are using AWS, we can definitely pull them in. But now you can see we've done, what Google considers the golden signals, your latency, throughput, concurrency, error rate, or utilization, throughput, So right now we are bringing that in. This is going to be your database health over here, and this is going to be your resource health over here. And this is across all 53 hosts that I'm currently running. And I can see my top queries, my top count, anything by time, by count, anything along those lines. And I can come in here and start typing, if I only want to see my Postgres servers, I can come in here, hit apply, and now it's going to graph it for all my Postgres servers, and it's already dropped it down from 53 to 15. X out, hit apply, boom, I've got all 53. So it's very easy to just see a top-down view of overall performance. And as he was saying, if I want to start drilling into what's going on particular queries or anything like that, I can come in here and go to the profiler. And again, now I'm looking at what my queries are doing. I'm looking, I can sort by their count or latency, anything like that. So I can quickly see which queries are consuming the most amount of time. Now, this is great. I can see that this is happening right now. I can change my time frame and go back. Right now I'm looking at the last hour. But we know in a development world, application world, a lot of the questions we may ask, and myself, I came from IT before, was, well, what's changed? This was working an hour ago. It was working yesterday. What changed? Did you do something? So I can quickly come in here and go, well, let's see what's changed. Let's go put in a marker and go, hey, show me what's going on now. So now I said, hey, what did it look like an hour ago? So again, I can completely see that this change that basically was this particular query was nothing an hour ago, and now all of a sudden it's dropped back up. I can sort by, percent change, anything along those lines, so I can start drilling into, okay, this is what has changed. I pushed out code. I can see that there's something going on, or we did an update. So I can come in here and start drilling in to this particular query. I can see what host it's on. I can see that, dude, it's going crazy right now. I have tags on there. So if I've tagged, hey, this is production, this is checkout, whatever it is, I can sort by these. And I can see that, hey, right now this is just on one particular host. So I don't have any type of load balancing going on here at all. So I'm going to come back over here and clear this out, remove this. So I can look at all my queries, and now I can come in here and I can see that this one's got issues. I can actually click into it. Let's see if this one's got, okay, so this one's great. I can see that this one's across multiple hosts. It's got staging, it's on API 1, web app 1. I can now come in here and actually start drilling into the query and start looking at the explain plan. So now I can have some productive conversations with my database administrator, my application developer, anything along those lines of, hey, this is what's actually going on. I can actually see sample text from that actual query. So again, now I'm able to have better conversations with my colleagues on, I think this is happening. I think this is happening repeatedly, or hey, this has had 112 occurrences and it's failed. So again, I can now have more conversation saying, hey, this wasn't happening an hour ago. This was happening an hour ago. I can look at my resources, so I can go look at a particular host and start drilling into it and what's going on with host A versus host B, anything along those lines where I really can get into the nitty gritty of what's going on. I can come in here and go, hey, again, I said what's new. I can come in here and go, let's go to my queries. Okay, I've got all these queries, but let's just search for new ones. So now, boom, oh, nothing on here. Let's remove this one server. So I've got that sort on there. I can see now I've got new queries coming in. So again, it quickly allows me to spot what's new. I can start drilling into this guest book limit query and start drilling in there and see again, explain plan for this, what's going on. It really is very flexible on how you do it. Again, you can create custom dashboards. Again, this one's pre-canned for golden signals for MySQL. You can do the same thing for Postgres or Mongo or any of the open source databases we support. So again, I'm coming in here and I can see all of that. I can see my resources. I pointed that out earlier was I can see my system resources. So if I want to start reclaiming some stuff in the cloud, it gives me a good ability to start drilling into those databases and the services for them and really start, working with across the aisle to get the resources where they need to be and the queries where they need to be, and really stop finger pointing saying, hey, it's the code, it's the network, whatever it is. I really can, buckle down and work with my APM counterparts to resolve the issue. So with that, I'm going to kick it back over. I hopefully think we've got some Q&A. I'm going to stop sharing, and it should go to the screen. And hopefully we'll ask David to come back. All right.
Absolutely, yeah. Great presentation. Really love the live demos. Thank you for taking time to do that. These tools look like they could really help a lot of companies out there to prevent, the finger pointing that I know happens at a lot of companies, unfortunately, and help to, improve application performance, which is just critical. So let's see. Let's kick off our Q&A, and while we do that, I'm going to bring up the poll question for everyone out there in the audience that you should see on your screen now that says, what additional information would you like about the SolarWinds database performance monitor that you saw a demo of here? So there's a number of questions coming in, Jared and Pete. I've placed those in your queue there. First question I wanted to ask you, though, is why do I need DPM if I have database metrics in my APM?
I'll take that. Essentially what we're seeing is that, your most traditional APMs are just going to say it's the database. I went in there and it took, 10, 15 seconds to query. That's all it knows. It doesn't know what actually happened. Is there a table lock? Is there blocking? Is there other resource contention from another application hitting that same database? So again, you're just looking at it from the application checkout, whatever it is, but not application refill inventory or whatever it is. So really, you're just only seeing, in my mind, like kind of half the picture.
Great point. Yeah. You're not going to be able to solve problems with only half of the picture. So next question here, they're asking how much configuration is required to get the transaction tracing to work?
Yeah, that's a great question. AppOptics in general was designed to be really simple to get up and running. You don't need services. And we've really auto-instrumented a good part of the product. You install a host agent if you're monitoring infrastructure. We say you install an application agent, but really just if you're going to monitor an application, you're just installing a small application library into your application and you're up and running. The transaction tracing is auto-instrumented. So it will, without you having to do any special coding or configuration after you've installed the application library or the application agent, It'll identify all the different services associated with that transaction, and it'll identify all of the services, whether it's a plugin you have to monitor it or not. So it's pretty straightforward and pretty easy to do.
Excellent. All right. I'm going to go ahead and move on here. We've got one more poll question that we also want to get out to the audience, and that is, what additional information would you like about the SolarWinds AppOptics solution? So we'll leave that up again here for a few moments. Next question on the list is, let's see, is DPM a new product for SolarWinds, and what databases does it support?
I'll take that. It is a new product to SolarWinds. It was formerly known as Vivid Cortex. It was an acquisition about a year ago, and it was rebranded Database Performance Monitor. And it supports your open source databases, Postgres, MySQL, Vitesse, Redis, Amazon Aurora. I think that's it. It supports 6 ones. I think I might be missing one off the top of my head.
Got it. Okay. Excellent. And then another question here, does AppOptics support monitoring serverless environments?
Absolutely. One of the more prominent ones is AWS Lambda, and we absolutely do. And it's not just a serverless environment. There's other elements of AWS Lambda. Matter of fact, in addition to the serverless Lambda environment, we support dozens of other AWS services. But absolutely, we support the serverless environment, and we're actually seeing, as people are moving to the cloud, that is becoming a bigger and bigger play, because a lot of people believe it'll be more cost effective if they just pay for what they're using. But we absolutely do monitor that environment.
Excellent. And then here's a question here from David. He's asking, would DPM or AppOptics help me with Microsoft SQL Server configuration? Would either one of these tools help with that?
Well, yeah, I was going to say, this is a Pete question. Yeah, unfortunately, DPM does not currently support Microsoft SQL.
Yeah, and AppOptics does support monitoring SQL Server, but the question was help you with configuring. Probably the answer is a no to that. Again, we'll monitor for queries and how long it's taking, and alert against the performance. But I don't think you're going to get any metrics that'll help you with configuring SQL Server.
Got it. Okay. And then there's a question here from Danny. He's asking, how is this licensed? I'm not sure which product he's referring to, but kind of what's the licensing model for both of these?
Why don't you go first, Jared?
DPM, it's just per instance. So it doesn't matter how many databases are on that. It's just a per instance, not throughput or capacity or anything like that. So pretty generic.
Yeah, and AppOptics is pretty straightforward as well, and actually pretty cost effective if you want to compare us to the other vendors out there. But it's simple as we sell, it's per host. We sell, if you can buy an infrastructure pack, which has 10 hosts and 100 containers, or you can buy a full stack APM, which includes both the application and the infrastructure. And again, the same thing. It's 10 hosts, whether it's an application or a infrastructure host. And if you've got more than 10 hosts or more than 100 containers, you just add another pack. It's that simple.
Nice. All right. Well, I'm afraid that's all the time we have here in our live Q&A session, but there's a number of more technical questions I've left there for you in the SolarWinds queue. Pete and Jared, really great demos again. Thank you so much for your presentation today.
Thanks for having me.
Yeah. Take care, everyone.
And for more information on SolarWinds, don't forget about the link that's there in your audience console in the handouts tab. That'll take you to Database Performance Monitor and AppOptics landing page. And from there, you can try out both of the solutions. There's links there to try out both, as well as to learn more about these solutions, how they work. There's a video there, everything like that. So make sure that you check that out. And with that, It's time for our next presentation here on today's EcoCast. I'm excited now to introduce Mr. David Cadelli, Product Marketing Manager at Red Hat. David, great to have you on. Take it away.
Hello and welcome. My name is David Cadelli, and I am a Product Marketing Manager here at Red Hat. I'm very pleased to be with you today. So my topic is event-driven architecture, and to sort of put things in context, I'd like to start by talking about how modern application architecture evolved from essentially monolithic application development to distributed application development. Now, it's a little bit unfair to say everything before us is monolithic, because to be honest with you, if you've been a developer for more than 5 or 10 years, you've been through some of these waves of major architecture changes. And it seems like every time there's a new wave, people say, well, what we were doing before was monolithic and now we're doing distributed. It's still true. It's really monolithic in context. So if you look at everything from mainframes, client server, application servers, 3-tier models, all of these architecture styles that preceded what's sort of the state of the art for today, every step became a little less monolithic in some context. The immediate predecessor, the architecture that dominated the 90s and early 2000s, the 3-tier architecture, is still monolithic in contrast to the way we do microservices development today. You still had one application server or a cluster of application servers, and you had one API generally that you're writing against or building, or one type of APIs, generally one platform, Java, .NET, something proprietary. And now what we're saying is we've moved to a world where we're breaking that particular monolith up. We're letting you have choice in your development platform. And at the same time, embracing things like DevOps, like 2-pizza team development, where we have these microservices, units of functionality, being built by different teams that are fairly isolated from one another. They use their own databases, they use their own practices, they have their own schedules, and they get a lot of benefits from that. They can move faster by having fewer dependencies. However, having fewer dependencies is mostly a good thing, but distributed systems still need to interoperate. So just because my 2-pizza teams are moving at their own schedules and they have their own databases, means that they still need to get data from other teams. In previous generations, they would do that with a shared API or shared files or various application adapters. And what's emerged in the microservices revolution is those don't work for microservices developers. They recreate those dependencies that we were trying to get rid of in the first place. So when you have distributed systems where each service is its own process, they run on multiple machines or VMs or containers or what have you, really 2 things have emerged as the standard for closing that interoperability gap. One of the broad areas is synchronous interaction, and the second is asynchronous interaction, which has to do with event-driven computing. So the first one, synchronous interaction, I'm not going to talk a lot about in this section because for microservices developers, it's more mature. The standards are mature, the practices are refined, and it's all about using well-defined APIs, offering a management tier above that, perhaps also a service mesh, and having ways of governing, discovering, and securing that interoperability. That's how microservices teams talk to each other synchronously. The other area is synchronous interactions. And in this area, the standards are emerging at a little bit behind in terms of pace of the synchronous interoperability. So asynchronous interactions is all about exchanging events and subscribing to events and publishing events. What is an event? An event is really anything that happens, any action, any occurrence, any change in state that originates either outside of your particular process space as a microservice developer, or it's generated by your process space, your microservice, and it needs to be shared with something else. Any change in the state that somewhere might have to be handled by software. That's what we call events. And then there's this related concept, event-driven architecture, which is really building software based solely on responding to those events, responding in real time based on the exchange of the events. And you'll very often see event-driven applications and event-driven architecture explained in a diagram like this, a sequence state diagram, which is really a graph of time from north to south and various entities, and then the events that trigger actions between these entities. Now, unless you're a newly minted Masters of Computer Science student right now, you're probably thinking, why are you telling me what event-driven architecture is? It's been around for a long time. And that's true. In 2002, the Java development platform introduced event handlers as first-class objects in Java code so that you could, instead of writing imperative code in Java, meaning this happens, then this happens, then this happens, and then maybe I wait for something, you could say, this is my event handler. It's code that's going to do nothing until someone raises that event. That's event-driven programming. And now there are probably older programmers maybe in this audience who would say, well, that wasn't the first case of EDA. There was older stuff than that. You go back to 1997, there were reactive programming languages that were completely built on that model of nothing happens until someone raises an event. And then there are database programmers that would say that wasn't when EDA started. Go back to 1993, the database vendors, Oracle and Sybase and Company, introduced notions of triggers, where you could attach business logic to someone putting a row or updating a row in a database table, and so on. Apple Macintosh 1984 had the main event handling loop. If you wanted to write a user application on the Mac, every program had this same loop while waiting for something, a mouse click, a menu open, key press, very low-level events that the programmer had to handle themselves. By the way, programming back then was very hard. And then, I'm not old enough, but maybe the real ancient programmers would say, no, 1953, we had the first computer with operating level system interrupts, where the operating system could stop your code and start someone else's code. That was really when event-driven programming started. So we have these things. All of those innovations were advances in the world of software development: interrupts, event loops, triggers, event handlers, and they're still in use today, and they still do cool stuff today. But they don't satisfy the needs of distributed, cloud-native microservices developers. Why? Because all of those things happen inside a single process space. Remember, we said the big innovation in this architecture is separate teams working on their own platforms, their own databases, and their own process space. So I can't pass an interrupt over that boundary. The interrupts in operating systems weren't written to do that. And to make it more complicated, the new microservices developers have needs for, they do a lot of things in memory. And so they have some needs, requirements that really hadn't arisen before. Things like replayability, because maybe I'm writing a microservice to track orders and I need customer data and I don't want to store it in my own database, but I want to store it in memory for performance. If I lose memory, then I want to rebuild that from something, from some state. And I want to do it in an event-driven fashion, which you'll see in a moment. So this notion of, hey, I need a stream of data that I can move forward and backward in, that's events. I need to go back to older events and replay them. And I might need to do something like streaming analytics to do real-time processing, to do things like, detect fraud. A whole host of new requirements that we didn't even know about because we weren't coding to this new model. So how do you get that? How do you build event-driven architecture around that? Let's talk about what makes up an event-driven architecture in the modern application architecture. Now, there are different ways you can do this. There are lots of streaming systems. However, what is emerging right now as the most popular platform for streaming is the Apache Kafka project. Kafka technology originally delivered or created at LinkedIn to handle massive volumes of parallel click streams for real-time analytics. Very sophisticated processing on literally a global web giant scale. So Apache Kafka was created, built to be massively horizontally scalable, built to be fault tolerant, commit log, and allows these distributed data streams and stream processing applications. And you'll see there's a word here I use, commit log. Essentially, the events that are shared are basically changes to everyone's reality, their database, or whatever their storage is. So anytime any microservice team has a change, they can optionally throw that into the Kafka universe and make it part of a stream that, security permitting, anybody can take advantage of. That was the vision fulfilled by Kafka. Red Hat offers Kafka, and we do it in a way that's particularly appealing to cloud native developers. We let you run Kafka on OpenShift, where you're building your applications. OpenShift gives you high availability. It gives you elasticity. It gives you clusters that you can scale up and down. And what we want is Kafka benefits from all of those things in a way that's comfortable and natural to our Kubernetes community. So we've packaged Apache Kafka with some other open source communities to deliver what we call Amq Streams. What is Amq Streams? Basically, it's everything you need to do to run Kafka in the cloud. So you get the core components from the open source Apache Kafka community, including the distributed commit log itself, Kafka Connect for interoperability, Zookeeper and Mirror Maker, some other components that help Kafka run in a cloud native world. All of them, all of the Kafka community. So you also get the consumer and producer and administration clients and the streaming processing systems. What we add is the Strimzy open source technology, which is a feature for managing and configuring Apache Kafka using what's called Kubernetes Operators. Now, Kubernetes Operators are the state of the art for deploying applications on Kubernetes. Essentially, you probably hear this from other speakers, but operators make Kubernetes much simpler to deploy, manage, and scale. And what we've done is we've taken those operators and inside the Strimzy community, which again, like everything Red Hat, freely available to you, we encourage you to join and participate. It allows that those Kafka components to be managed with operators so that they're basically easy on Kubernetes. And Strimzy, like Kafka, has been accepted in the Cloud Native Computing Foundation as a standard, as a leader technology for achieving that bind between Kafka and Kubernetes. In addition, in another open source community, we've built with our colleagues in that community something called change data capture. What's that? Well, remember that Kafka is all about sharing events between systems. And it's a little bit like, hopefully this analogy is not getting too tired. It's a little bit like a telephone. If I'm the only one that has a telephone, it's worthless. If I'm the only one that has Kafka, it's worthless. It's only when I have other people who have telephones that I can call does a telephone and a telephone network really become useful. Well, the same thing's true with Kafka. The more applications that I can get to participate in my Kafka streaming systems, the more valuable it is, the more insight I can gain. And change data capture is a way of boosting the number of applications that can participate. Essentially, you have all these databases that have database triggers built in. Our change data capture technology is essentially an agent we can fire with those triggers to automatically generate events and send them on Kafka streams. So a minimally invasive way for you to essentially onboard your applications so that the data that you are analyzing with your streaming applications is richer and more useful and more likely to yield insight. The open source community behind change data capture is Debezium. You can go there today, you can download it. It's based on reading database transaction logs. It has snapshots, it has filters. It's widely deployed in production, even just the open source. And of course, you can get it from Red Hat with our integration technology, fully supported by our very well-regarded support and services team. So what differentiates Red Hat in the world of Kafka is an enterprise supported distribution of Kafka that we test thoroughly, tested on Kubernetes thoroughly, with an open source CNCF recognized binding layer called Strimzi between Kafka and Kubernetes. And that's really important. If you're going to run your Kafka on Kubernetes, get your Kafka from someone who knows not just Kafka, but also thoroughly established in the Kubernetes world, as Red Hat is. We are #2 contributor to the Kubernetes community after Google. So we know Kubernetes, Kafka is going to run great on our OpenShift. And as I mentioned, gives you everything in containers, so you can use those operators to quickly get up and running with Kafka on Kubernetes. Also, I talked about how important change data capture is for Kafka projects, especially big Kafka projects. Another great advantage is our Camel support, the Fuse technology and Red Hat integration, because, of course, when you cast this wide net and you bring a lot more applications in and you want to do streaming analytics, chances are you're going to need to do some pretty sophisticated routing and transformation. And that's where Camel really shines. There are a lot of Kafka technologies that don't offer graphical, pattern-driven routing and transformation, but you can get that with Red Hat's distribution of Kafka. And not only transformation, but of course, if you're doing streaming analytics, we have great rules and decisions and workflow technology as well. So where are we going from here? I want to put in a quick plug for some of my colleagues who've built this really cool technology called Quarkus. And Quarkus is essentially reactive Java built for serverless. The knock on Java has always been it's slow, it includes a lot of stuff, it's big, it's heavyweight. It's not Quarkus. Quarkus gives you all the power of Java in a way that's supersonic and subatomic. What do I mean by that? Supersonic means startup extremely fast, much faster than Java, probably much faster than any technology, Node, or others that you're going to use. You should go to this website and see our benchmarks. It's pretty amazing. So, supersonic, subatomic, scale to zero rapidly. That makes Quarkus a great technology for you to build your serverless applications on. And of course, hopefully you'll hear in other sessions, OpenShift now has serverless, now has implementation of Knative. So this combination of Quarkus responding in serverless to Kafka events and scaling up and scaling to zero rapidly is really compelling if you want to be serious about serverless applications and take advantage of the elasticity and huge efficiencies you gain by moving to a serverless model. Okay, well, here's the product slide. Well, I did mention some of our products, but we hope that you can participate in all of these open source communities and that you can learn about us, learn about the things we've contributed, and if you're ready for a complete package that gives you everything you need to build applications that interoperate with your greenfield and brownfield applications, please come look at Red Hat integration, Red Hat runtimes, and Red Hat process automation. Runtimes is for those greenfield applications. It's essentially Quarkus and a number of other things that cloud native developers love to build new, efficient, and elastic applications. Red Hat integration includes things like Kafka, like transformation, like routing, as well as our API management. So this is where your cloud native developers are going to get that interoperability, both synchronous and asynchronous. And finally, if you're doing rules processing or if you're doing human workflow steps that you want to orchestrate inside your new applications, please have a look at our Red Hat process automation with some great rules technology. That's what we call our Red Hat application services. And of course, all runs on OpenShift, physical devices, virtual, private cloud, public cloud, truly an embrace of the hybrid cloud. Just a few stories. We came out with our implementation of Kafka about a year ago, a little over a year ago. And so this company, Helvetia Insurance in Switzerland, was the first to go into production. Great story. They love talking about it. They've embraced the microservices model. They have a lot of IBM Big Iron that they need to get data from to build responsive web applications that are delightful for their users. And so they do greenfield application with the state-of-the-art cloud development platforms, and they use Red Hat integration and Amq Streams, our version of Kafka, to stream events between those applications. So very modern, almost a case study in the approach of agile developers doing state-of-the-art cloud-native development and being able to reach in to legacy systems that have valuable data, that have digital assets, that make those applications that they build for the users more immersive, more interesting, more useful. I hope that I've whetted your appetite to learn more. We have a number of free resources. Only some of them are product commercials by Red Hat, I promise. So just a quick tour of some of the resources. We published a book on building event-driven applications with Red Hat Amq Streams. We do talk about our Amq Streams product, but really it's more a survey of what you can do with Kafka if you're doing cloud-native development, what it's going to take to get it to the cloud. We also have a technical blueprint, the EDA blueprint for what are the components, what are some best practices for event-driven architecture, a few blogs that are teasers for more information, but again, they're giving you hopefully practical advice drawn from our customer experiences on the event-driven architecture road, and then a nice video showing really again that what hopefully I've already explained, but where is the boundary between event-driven architecture and microservices? How do microservices developers capitalize on event-driven architecture? And with that, we come to the end of my presentation. It's been my great pleasure to talk to you today. Thank you very much, and have a great rest of your day.
right, really cool presentation there from David at Red Hat. Really cool stuff that the Red Hat team is doing there. So much innovation. I've just brought up the poll question that says, what additional information would you like about the Red Hat solution? And I'll just leave that up while we announce our first prize winner. We've got an Amazon $500 gift card, and that's going out to Peter Crisano from Massachusetts. Congratulations, Peter Crisano from Massachusetts. 2 more gift cards still to give out on today's event, so make sure that you stay tuned for that. And I'll leave this poll question up here for just a minute longer, allow everyone a chance to answer the poll. We do appreciate your responses. The Red Hat team really likes to know, what you thought and what additional information you would like. All right, thank you everyone who responded to the poll question. We do appreciate that. And with that, let's move on to our next presentation on today's EcoCast. I'm excited to introduce Mr. Michael Frederick, Developer Evangelist at Gitlab. Michael, great to have you on. Take it away.
Hello, everyone. Today I want to share some insights about how to identify, analyze, and action on CI pipeline monitoring. And this is a really hot topic, and I'm trying to cover it in the next 20 minutes. We're going to have a short introduction. We're meeting CI with monitoring. We're going to identify certain problems in pipelines. We want to analyze the insights, and we also want to dive into job stages and resources. And we also want to define actions based on that. Last but not least, we're looking at things to cover next. A little bit about myself. I'm Michael. I'm a developer evangelist at Gitlab. I'm thinking of everyone can contribute in every way. In my spare time, I prefer to build Lego models, and you can reach out on social media as DNS Mickey to myself. A little bit about Gitlab. The company was founded and incorporated in 2014. Right now, we have around about 1,300 employees all over the world. So we are an all-remote company. We have many organizations using the DevOps lifecycle, and we also have a strong open source community with many contributors, and we keep improving GitLab every day. But let's look a little bit more into monitoring and how this relates to CI. The thing is, when we're talking about specific use cases, this is a quote which I found really usable in the sense of like speed to market is an overriding concern for firms offering digital products today. Those who can manage the speed, leverage it to discover products and services via market exploration and feedback. So what does this tell us? In a specific sense, we want to deploy and develop faster and also release faster. This also means we need to increase, we need to speed up the feedback loop. So it's kind of defining specific workflows upon this. In a specific sense, this means we want to build a project. We want to measure it, like the runtime and performance indicators, but we also want to record the test reports and possible failures. Then we say, okay, we want to learn, like improving the process, and we repeat the process as well, especially because you add one feature and you go on and on and on, and after a while, you're going to release that. There is a specific risk with that, especially when you start the first time with CI/CD. You add it to your existing project. Everyone starts exploring what's possible, CI jobs. There's lots of trial and error involved. Sometimes it's located to the YAML file, the syntax. There might be long pipeline runtimes because the script is running for 10 minutes. The reviews are being blocked, actually, so you cannot do any release reviews or reviews from merge requests. The CI feedback is not really fast, so you're kind of sitting in front of the screen and waiting for the pipelines. And at some point, you figure, I might need some optimizations. We do have created, based on this webcast, actually, a new documentation about pipeline efficiency, which is linked at the bottom. And the thing is, we want to help you improve upon this and like to mitigate the risks and especially reduce the risks. So if you imagine a typical merge request workflow means you create an issue, you work on a feature, you branch of the master branch or the main branch, you create a merge request, you start working on a feature or your changes, you commit them, and then the CI pipeline is going to run, the security tests are going to run, and then you get some insights, which could be test results, runtime durations, and other things. And this is an ongoing process, so there might be 10 MRs a day, there might be 1 MR. It's the workflow which benefits you best. In case you want to identify a specific insight into a CI pipeline problem, one thing is the pipeline duration. So this kind of means how long does the test run, the script run, anything else. This is influenced by the number of stages and jobs, obviously. You might have also dependencies between jobs. So this is a sync run. One job only starts after the other one has been finished. And you want to be looking into the critical path, which means the minimum and maximum execution time of the pipeline, so-called pipeline duration. This is one key element to analyze and see whether the pipeline is efficient or not. The other one, or the other identification method, is to look into patterns with failed jobs, which means you want to analyze whether there's flaky unit tests. Sometimes they return okay, sometimes they do not. They are influenced maybe by network latency or something else. And also, like, there are other patterns with test coverage being dropped, and in general, build dependencies which influence the runtime, containers being built, and as said before, the network latency, pulling resources from the internet and everything else. When we have analyzed specific problems, we want to, or identified, we want to analyze them further. So there are given tools and given methods which allow us to gather more insights into a pipeline. One way to do it is you navigate into the CI/CD analytics in GitLab itself. You can immediately see the average duration from the past 30 commits. And you also get an idea about the failure and success within a chart. So it's visualized and you kind of see whether the pipeline is healthy or not for this project. Another method to get an insight is you can install unit tests, or you should install unit tests for your code. You can run these unit tests from CI/CD jobs or from CI jobs on each commit and whenever the merge request is being created and updated later on. From these tests, you can generate coverage reports, which then provide you an insight into test coverage. And going further along, there's a JUnit integration in GitLab, which works for Golang and everything else. And another idea is, for example, to publish these HTML reports to GitLab pages, even to get an idea. The basic overview, the basic feature discussed here is the integration directly into merge requests. So you get an idea what the job and the tests are doing, if they are okay. The only thing is you need to define it for your programming language and how it feels, how it looks like. Because we have a variety of programming language around, so there's like 20, 30 different ways to run unit tests, but this is one way to go. The other one with getting a more detailed insight is what I mentioned before, the critical path, the pipeline duration. There is a way to analyze this with dependencies, or to speed it up with dependencies. So you can create sort of an direct acyclic graph, which means you run asynchronous jobs. They're not dependent on the stage, but they run. But the thing is, from the default view, you might not see that. But from a specific visualization layer, you can analyze the critical path and see, for example, that from format to unit test to compile to run, this would be the critical path. And you need to dive into further because the complexity increased and the build run times, for example, exceeded a certain threshold. Going a little more into deep from the jobs, pipelines, and resources view, we also want to analyze the problems and also visualize the problems. We want to see whether the workloads are okay. We want to identify and analyze bottlenecks. Maybe there were too little or too much resources assigned to the job runners. And we also want to understand the global picture. It's not just one project being affected by a problem. It could be more than that. The other thing we want to do is we want to understand the flow and discuss possible actions to resolve the problem. So we might refactor the pipelines. We want to reduce the costs because there are too many computing powers currently needed to run the jobs in the cloud, and there might be specific things to reduce the costs. And we want to have some insights. So basically, we have the pipeline health, and I showed you before, there's the analytics CI/CD. Another way is to access the REST API and use that to leverage and integrate with external monitoring systems. There's also the possibility to look out for monitoring tools like Zabbix Scenarios or Singer Sensu using the Check GitLab plugin, which is a script which queries the REST API of GitLab and extracts, for example, the duration or the health status. And one way I've found pretty convenient is to use Prometheus, a specific GitLab CI pipelines exporter, which has a rather convenient or quick Docker Compose demo to get started. And also has a Grafana dashboard as a demo built in, and provides you a specific overview of your CI/CD pipelines, the duration, the failure, and you can immediately see what's going on. So in this example, for example, the CI/CD playground project failed for some reason. And one of my projects actually has a runtime or an average pipeline duration of 27 minutes, which is not that good. And as you go along and you learn Grafana and Prometheus, the query language, you can exercise on that and create your own dashboards, integrate it into your monitoring, define alerts, and so on. Another big point is to analyze the storage consumption. For example, you have artifacts for jobs which are defined by expire in, so they might get removed if you don't add it to your configuration. It might pollute your database, your backend, and make the execution of other jobs even slower. The other one is artifacts affecting storage. But there are also container registry images, which might get huge and slow down the overall process. Given the network traffic, you might have a low latency connection or a slow connection, and the CI jobs install software in every run. So dependency, it's pip install, it's Python install, it's npm install, everything which gets pulled every time. On the other side, you might have huge Docker images like 1 gigabyte or more. They are being pulled every time. Why is it 1 gigabyte? Is it an all-in-one image? Could it be solved differently? Looking into the CI runner, which is kind of the daemon executing the job, this guy, your CPU usage, everything which is important for Linux, Windows, macOS specific host. To get more insights. Last but not least, I want to highlight or mention we have custom metrics which we can collect in jobs. So you can create a timing point with a start time and an end time and export that for being used in a merge request widget, for instance. This could be one way to do it and to dig deeper into this. Another way of getting fast feedback in a merge request is to integrate the tests and reports directly into merge requests. So we have test coverage visualization. We have the possibility to expose artifacts in there. We can add our own metric reports. We can add JUnit test reports. We have code quality, which is available for everyone. We have accessibility testing. And of course, we have security reports. So there's static application security testing, dynamic application security testing. We have container dependency, secret, license scanning, everything around this. So everything you can move into the context of a merge request and the review cycles makes this easier to analyze and speed up your development lifecycle. Another way of immediately getting to know what is the status of my pipeline is the ability to use batches. So you can configure that directly in the project settings. You don't need to edit the README MD and extract some weird URL or something like that. You get it in the project settings within GitLab itself, and it can be used, for instance, to cover the CI pipeline status or the test coverage reports, for instance. Now, after having identified and analyzed everything, we want to define some actions based on that. One action is if you have a blocking job, which is the code quality job in this example, because everything failed already, so the formatting job said the code is not valid, it doesn't make sense that code quality is running until infinity. In this example, it runs, I think, for 7 minutes or something because it's analyzing everything. And the solution would be fail fast and say, okay, the format job executes in 5 seconds, move it into a stage before, let it fail fast because code quality isn't even triggered afterwards when the stage before failed. This is one way of doing this. Other ways of optimizing the CI/CD infrastructure is when the Docker pull takes quite a while. You want to analyze the base images. You want to make them smaller. Maybe use a Cloud Container Registry next to you and not Docker Hub. It's also possible to create your own Docker image and use the GitLab Container Registry, for instance. The other point which I mentioned before is that the CI jobs install dependencies every time. Meaning to say, in this specific case, create your own Docker images, rebuild them on demand in a dedicated project, and also think about adding of caching layers for node modules, for Ccache with C++, and specific other things. I've also put a quote over there with PHP, which reduced the total runtime of the CI pipeline and made it even better with just a small iteration on caching and improving the Docker image as a base image, for example. Other examples of how we at GitLab use GitLab, we're using an interruptible keyword to stop pipelines which are out of date. We kind of run tests only when needed, so kind of skipping backend tests only on the front-end changes and reducing the number of tests which are necessary for production. And we also try to decrease the test setup duration and also improving the caching between jobs. So you can follow this epic, which is linked over there to see how we go along. This is a never-ending process, but it's a good one. The other thing I want to highlight is you should test, document, and share. So everything which helps improving your CI pipeline efficiency should be documented. You can test, for example, auto-scaling the CI runners. See how it goes, document the offline times, test it out. Link everything together, everything which helps within a merge request. You want to maybe add monitoring metrics, traces, and alerts, everything kind of which speeds up the process and the learning iteration. You also want to share this with your team, like updating incidents and issues, iterate on everything you want to try out. And in the end, share and document all the information you got. Last but not least, learn how to fix pipelines fast. Everyone should be able to understand the failures quickly. You want to have key messages in your output, colored messages, maybe even link troubleshooting docs to your wiki or directly into GitLab. You can also use the Mermaid Markdown to document the pipeline design and create issues from everything you've learned thus far. Last but not least, build meaningful dashboards and manage the incidents. Make runtime data useful in teams building dashboards for operational visibility, and think about incident management. So what's next? Look into the DAG, the asynchronous jobs. Go into the continuous delivery, continuous deployment direction with staging and production environment. You have application performance monitoring. You have cluster Kubernetes cluster monitoring. You might be looking into more pipelines, visualizations, and REST APIs. And you should totally check out the GitLab CI pipelines exporter for Prometheus. Is just a quick overview how this could look like. On the right-hand side, this is the task you should be looking at after reviewing the things you've learned today. And with that, I want to say thank you. I've linked specific more resources over here. And that's about it from my side. And I would say we're right on time with 20 minutes. Let's look into some questions. And I can see we do have one, like GitLab has its own monitoring tool. Why is the external monitoring tool not integrated into GitLab? So previously I've showed you the Prometheus node exporter and Grafana dashboard. And yes, it would be super nice and super convenient to have everything integrated into GitLab. But on the other side, our community is faster than our engineers and our product vision. So it's great to have the REST API with all the metrics attached and available. And we do have the possibility to just use that, integrate that. And probably you already have your own monitoring environment with Prometheus, with Grafana, with the different metrics, tracing, observability, mechanism of functionality. And you can just integrate it. There's no need to use everything within GitLab, but using an external monitoring for GitLab, for the CI pipelines, for the resources, for maybe even monitoring the Linux host or the Kubernetes pod, which or Kubernetes node, which will be running the containers. Another question mentioned is like Kubernetes or deployment. This is not directly covered in this webcast, but as I said before, when you want to have specific insights into the monitoring area, and let's just switch back a little over here. Let's go over here, Kubernetes cluster monitoring. I think, yeah, some portions are mentioned in the CI pipeline efficiency documentation. This can be helpful in the sense of like installing kube state metrics, which provides Prometheus metrics, more insights into the pipelines being run in Kubernetes. Another thought is to specifically monitor the application performance and the resources consumed by the application, and comparing that from each commit over time, so you can immediately see whether your refactoring of the code influenced the performance of the application, and memory consumption was doubled for some reason, maybe a leak, maybe something else. And this is key to even getting more insights into your application, your layers, and things like that. Yeah, and I think we do have another question in this regard. What metrics should I start looking at measuring first? What will be most useful to help my development teams work more efficiently and be productive? So I would say start looking into the duration first, because the duration of jobs, like the runtime, is the most important insight you can get like for free, because it's already there. We do have plans to visualize that better and see the runtimes and get an overview on a CI/CD director level dashboard. But up until then, you can find ways to visualize the pipeline duration and get an idea and say, okay, my jobs need to fail fast, as mentioned before, or maybe I want to improve and split up the jobs, because one job is like testing everything, and you are not convinced by this. So it might be a good chance to split up the 5-minute job into actual like 5 different smaller jobs. And if one of them fails, it's no problem. It's a good idea. It just like stops the pipeline. You get the feedback, oh, this job actually failed, and you can fix the problem. Yeah, and for more metrics or for more things looking into this, I would recommend to read the pipeline efficiency documentation, which kind of contains the whole brain dump of myself and doing all these things over the past years. Try to optimize everything, but also keep it small, iterate, work with your teams, and don't stress it. Just ensure that everyone is in the loop. And with that, I would say we have no more questions. Thanks for listening and happy monitoring.
All right, cool presentation. Thank you so much to Michael there at Gitlab. Really cool stuff. For more information on Gitlab, make sure that you check out the Handouts tab, and it's there that you'll find a link that will take you to the Gitlab. I hate to even call it an ebook because it's just really cool, and there's tons of resources on the left. It's almost like an e-magazine, if you will, on maximizing and controlling your CI/CD pipeline using the Gitlab solution. I've just brought up the poll question that's on your screen there. What additional information would you like about the Gitlab solution? And I'll leave that up while I announce our next prize winner. Oh, no, wait, not yet. That prize winner is coming up after our next presentation, so make sure that you stay tuned for that. Before we go on to the next presentation, don't forget about answering that poll question there on the screen. All right, thank you everyone who responded to that poll. And now I'm excited to introduce you to our next presenter on today's event. That is Mr. Jeff Edwards, Community Evangelist at Progress. Jeff, are you there?
Hey, I'm here. Thanks for the introduction.
Absolutely, yeah. Thanks for being on, Jeff. Take it away.
All right, thanks. As I was saying, I'm the Community Evangelist or Tech Evangelist for Progress What's Up Gold, which is a network monitoring tool. And I'm going to talk to you guys a little bit about optimizing your IT with unified monitoring of your full network and your full IT stack. You can move on to the next slide. Thank you. So we're going to talk first about some of the critical business issues in IT regarding to network monitoring. Then we will talk about the changing face of the network landscape. And finally, the advantages in a unified monitoring approach, and of course, how What's Up Gold can help you achieve that goal. And then I'll have a little bit of time for questions, so we'll take some questions at the end there. And we'll head to the next slide. All right, so what are some of the critical business issues affecting IT in regards to network monitoring? One of the most common issues we see is a siloed approach to monitoring where you have different tools for monitoring your on-premise servers. You might have a separate tool set for monitoring your applications and a separate tool set for monitoring each one of the cloud platforms connected to your network, and that can cause a lot of issues from IT down to lines of business. So that's what we're going to talk about in the next few slides, and we can advance now. Thank you. So all teams at one point or another have to react to unplanned service interruptions. But really, what is the great separator in IT is whether the majority of your IT management is reactive or proactive. So what do we mean by that? So some teams are able to identify the vast majority of issues before they're reported by users rather. The degree to which your team is reactive versus proactive is typically measured by the percentage of service-affecting incidents that you first learn about from users versus the percentage that you find out about on your own. The more reactive the team, the less they're perceived as a valuable asset to the organization. In a lot of studies and analyst reports, reactive management is correlated strongly with siloed or point-specific monitoring deployments. So you may not be able to see exactly where the issue is coming from if you found it on one monitoring tool, but the issue actually comes from physical servers, for example, if you've found an issue with your virtual machines, but the issue comes from the first physical device hosting them. The causal effect most often stems from the inability to integrate data between organizational silos or gain end-to-end visibility across technology domains. So where does that take us? In the next slide, we'll see, we can change now, that's going to take us to longer troubleshooting times as well as lowest service, go back one. Thanks. As well as lower service levels. So when you have a disruption that you can't pinpoint the cause of, it's often going to trigger meetings, conference calls, big time wasters in which SMEs are going to be comparing the health of their individual domains in an attempt to find the likely cause of the issue. But since what might pass as a healthy condition at one level can actually cause issues in another, it can be really difficult to ascertain the true cause of the problem. This siloed tool monitoring approach often adds a lot of delay in your mean time to repair, especially in more complex IT environments. While this also can lead to sort of turn it on and off again approach, which might restore service temporarily, but as every IT professional knows, it can also just add another known problem to your list of problems, and over time an increasing number of unresolved issues can stack up and resurface, resulting in even further high incident rates. So next slide, please. What that all leads to is wasted personnel, wasted manpower. So when each management tool used requires a degree of dedicated personnel to operate and maintain that tool, you end up using more of your people to do sort of the same task. Often tools are selected based on the degree to which they can be customized with a certain approach in mind. So you might pick, to use virtualization as an example again, you might pick the most customizable virtualization monitoring tool, but you may not consider the ease of customization and the ease of integration with the rest of your stack. So then as the number of tools grow, it becomes a personnel drain on resources that can negatively impact productivity. Often we see as IT teams mature, they place a higher degree of emphasis on ease of automation and a smaller number of tool vendors. So next slide, please, David. Thank you very much. So that is some of the business concerns of siloed monitoring, but now let's talk about some of the technical concerns. So as we're all aware, the world has become a lot more complex in the past decade, technologically and otherwise. IT, of course, is no exception. Even before the pandemic, IT departments have been experiencing a sea change in network connectivity model for years. So the rise of cloud computing, software-defined tools, hyperconverged infrastructure, among other things, that's all upsetting your traditional network architecture. But in many ways, monitoring network performance hasn't gotten less important. It's more important than ever, really, to the success of your business. And as the network becomes more complex, so must the monitoring system. In the past, many organizations achieved monitoring using a combination of various applications. Like we talked about, that's the siloed approach. And that might include open source or even homegrown monitoring tools. A lot of organizations still use open source command line interface tools. But these siloed monitoring stacks really aren't sufficient or even very relevant in the face of a hybrid environment. So today, 93% of enterprises have a multi-cloud strategy, and 87% have a hybrid cloud strategy. That means that the network is no longer constrained by the corporate firewall, and network visibility can't be either. In hybrid environments, well-performing network is still critically important to digital business projects, but the level of network agility and visibility often fails to meet the requirements of these initiatives. Siloed network monitoring stacks with one tool for monitoring your network devices, another for applications, and more for each individual cloud platform connected to your network can just obfuscate your visibility into the overall going-ons of your network and how your cloud, on-premise resources, virtualization are all working together. The key to future-proofing network monitoring is investing in network monitoring tools that provide the required level of visibility in hybrid environments, including edge network and cloud network monitoring. Even in on-premise networks, the type of devices that connect to the network are changing. So we have a lot of mobile IoT and operational technology endpoints that are now connecting to the network, and they're not really bound by the traditional endpoint and infrastructure components that legacy network monitoring tools might be familiar with. This influx of devices is really forcing us to accommodate new types and new patterns of traffic, which can be really difficult for tools to ingest and analyze, especially siloed tools. Software-defined architectures too, like SD-WAN, like software-defined wide area networks, that's really can prove difficult to monitor and manage. And then virtualization, of course, too, which has been around a while longer, but still can cause challenges in visibility, especially when you're attempting to monitor VMs with SNMP. So finally, the last point here I'm going to make is that as digital business initiatives become increasingly critical to your lines of business, coworkers outside of IT are looking more and more towards IT operations, network operations, to help them realize business critical projects. As such, the network operations team's ability to guarantee the performance of the network and the applications that run over them becomes more and more important. To meet this guarantee, network monitoring needs to rise above the basic level of infrastructure monitoring, and it also needs to provide more application level views, and that's where unified monitoring comes into things. So next slide, please, David. So what is unified monitoring? In my perspective, a unified monitoring platform is one that gives you a single end-to-end view of your network. You can see the physical devices on the network. You can see the virtual devices or systems running on those devices, and you can see your cloud infrastructure all in context. Along with the deployment patterns, you will want a physical map of your network to give you views into interface. You want to be able to see bottlenecks, dependencies, all of that. So a dependency-based approach to monitoring individual domain elements is really important to unified network monitoring. For instance, knowing the scale of virtual workload running on physical servers and the relation therein, that will allow you to dictate the thresholds and severity that you apply to performance for alerting, and that's one piece of seeing the interaction between different pieces of your network in context. So when IT monitoring is based on this knowledge of dependencies, it's more likely to identify potential or developing problems, and therefore you're going to be able to use that unified monitoring approach to be more proactive, as we were talking about in the beginning. Networking, server storage, and application teams are then going to be able to work together more efficiently when they're all dealing with the same information. That's going to lead to further, faster problem detection and resolution. And those teams that better understand technology dependencies for the delivery of those business applications and services are going to be able to quickly identify the cause of problems. But every IT environment is different, of course, so your monitoring tool, in order to be truly unified monitoring of the full stack, needs to have the flexibility to handle a wide range of use cases, devices, and protocols. And software licensing also needs to be flexible to support growth and changes in your environment. You don't want to just be able to monitor one type of device or to be hamstrung when something new comes along and joins your network. You want to be able to monitor new devices and applications without buying additional licensing. Of course, being able to detect solving problems and take proactive steps to avoid them decreases incident rates, and so does being able to diagnose the cause of the incidents. So as causes are identified, problems can be fixed, and a list of known problems can be decreased. So the largest benefit really of unified monitoring for IT teams is the impact on your service levels. When you're able to meet aggressive SLAs, you can worry less about network availability, you can worry less about end user response times, application performance, and you can increase your focus on the overall service quality factors like faster and smoother deployments of improvements. And finally, unified monitoring. It's going to go a long way to decreasing the number of silo-specific tools that are actually needed. Not only does this translate to a more productive use of personnel, it also means reducing costs and licensing, maintaining, configuring, training, and upgrading. So that's unified monitoring in a nutshell, but now let's talk about who benefits from it. So next slide, please, David. So who benefits from unified monitoring and how? There are three primary benefactors. You have your sysadmins, your network admins, and your IT directors, but that's not only limited to those people, but that's the who we're going to be talking about now. So an adage from the world of professional sports I'm going to use, they say that an umpire in baseball is doing their best job they can when you forget that they're there. So in many ways, the same thing could be said for a sysadmin or a network administrator. The administrator is doing a good job when the network's running so smoothly and so efficiently that the users forget that you exist. Because as you know, as an administrator, second there's a problem, they're all going to remember you and they're all going to come around and bother you. So that means the primary job is to keep tabs on the network and ensure that it's operating normally. Information about the hardware and software on the network is key to performing this task properly, and that's where monitoring comes in. When networks were small, an administrator could stay informed about the status of hardware and software via simple means. You could physically walk over to a computer and check on it, right? Or use a low-level link layer management protocol. But that's really not sufficient anymore. It's not really possible with modern networks, which are large, geographically diverse, and often consist of many different lower layer technologies. So usually the only thing all the devices on your network will have in common is the protocol, such as TCP or IP. So this makes the network itself the logical way to facilitate communication of network management information between devices and network administrator, using that unified network monitoring approach. So for a sysadmin, the main benefit is seeing the problems in context and getting awareness of problems from alerts before the users are aware of problems. There are added benefits to unified monitoring, such as inventory reporting, which will help you take care of some of the more tedious parts of the job. There's also configuration management is a good benefit, but the context that you get from seeing your physical, virtual, and cloud infrastructure all in one place is the main benefit. For network admins, sort of a similar benefit. You can continuously monitor your entire network infrastructure, whether on-premise or in the cloud, and you can use the monitoring tool to leverage your workflows and leverage fixes faster in configuration, custom alerting, dashboards, reports, all of that for that in-context visibility. And again, the bottom line really is that you're able to resolve network issues quickly before end users call or submit tickets. For the IT director, it's sort of similar, but on a higher level. You want to ensure that you're meeting SLAs, mean time to repair, for example, and you want to know the network reliability as a whole, the capacity. You can use these tools for capacity planning, for example, to build out your network further, and to get a baseline for network performance, so you are always prepared to meet the changing demands of that SLA. Also, finally, allows you to do more with less staff and operate within your budget, which everyone likes. So now I'm going to talk a little bit about the offering that Progress brings to the table, which is What's Up Gold on the next slide. So What's Up Gold is a comprehensive end-to-end network monitoring tool that is going to give you that unified monitoring view of your environment. What it really gives you is network availability and performance at a glance. It lets you view your on-premise devices, your virtual machines, your cloud infrastructure. We have application monitoring, network traffic analysis. All this is available with What's Up Gold. We really focus a lot of time and energy on making our product easy to use and deploy, but that doesn't mean that it's not capable and highly customizable. We do have advanced discovery capabilities that are going to automatically place everything connected to the network on a unique interactive map, which if you can see the slide now, I still have the server error, but if you could see the slide, you could see our map, which is essentially, we have icons for each device. They may be green or red, which is a quick way of telling what's up or down. And then you can see dependencies between devices, as well as the net flow, which also could be green or red, depending on how smoothly things are operating. If there's a bottleneck, for example, it will be a red line. You can also see an inventory screen, which will have every device, and you can see all of that in context. And from there, you'll be able to initiate troubleshooting and administrative workflows directly from either the map or from a dashboard, so that you can find out what's going on quickly. The discovery process applies out-of-the-box or custom device roles that you can configure before discovery, and that's going to accelerate the monitoring setup as well. So common devices, we have about 200 built-in device roles that you can use for common devices, but you can also set up however you want, and that is going to automatically apply alerting rules to that device. It's going to apply dependencies and configurations as well, and you can even use that to do bulk configuration changes or resets, all types of things to bring down the tedium of network management. So why WhatsUp Gold over competitors? The primary benefit of WUG is that unified approach. We can monitor devices, applications, virtual infrastructure, wireless. We do monitor Meraki and SD-WAN as well. And cloud infrastructure, it's quite customizable as well. We have REST API support. We can really monitor anything that you can ping. And you can set up actions, action policies that will run scripts to restart devices. You can set up password reset policies, all types of things. But the typical main benefit that our users get is ease of use, the ability to see everything in context and to do all this from one screen. And not only is the product easy to use, the licensing is simple and easy to understand as well. So we do device-based licensing. There are some network monitoring tools that still use point-based licensing, so that would be one license, 1 point on your license is going to represent one monitor. So if you have a 1,000-point license, it might sound like a lot until you try to monitor every port on a switch or something like that. You know, if you're monitoring every port on your firewall, you're already using potentially 1/10 of your license right there with one device. So in WUG, each device represents 1 point off the license. So it doesn't matter to us whether you apply one up-down monitor to a server or 20 monitors to that same server. It makes no difference to WUG, and that's one of the key benefits is that you can really customize your deployment of WUG. You can choose, here's what I want to monitor today, this week, and here's what's important to me this next week, and you're not going to have to change your license to do that. So that is WUG in a nutshell. I'm sorry that we can't see the slides because there's more I'd like to share with you and show here, but we can move on to the Q&A now. And if you want to know more about WUG, you can visit whatsupgold.com. We do have everything there from data sheets to webinars to ebooks, and we do have a free trial as well that is 7 days fully featured. There's a free version as well that is not on a time limit, but that would be limited to 10 devices. You can find that on the site as well. So with that, I'll let David take any questions.
Yeah, absolutely. Excellent presentation, Jeff. Thank you for working through that technical issue there. It looks like the slides and everything have now been magically fixed now that we got to the end of this. But the good news is we've just brought up the poll for everyone out there in the audience. What additional information would you like about the Progress software solution? And we'll just leave that up while we do some Q&A. So first question I wanted to ask you here is, does WhatsUp Gold support SQL Server 2017 still, they're asking?
Yes, it does.
Okay. And what about Meraki devices?
Yeah, as I mentioned earlier, we do have a custom API with Meraki. So you have a full suite of monitoring capabilities there that don't rely on SNMP and go through the Meraki API and pretty much monitor anything you could monitor internally with Meraki. You can get through your dashboard in WUG.
Nice. There's a question here from Alex. He's asking if you all support HP Aruba devices.
Yeah, I believe we do.
Okay, nice. And then another question, what about voice over IP? Is that something that WhatsUp Gold can monitor? Yeah,
so if you're monitoring on-premise, you can monitor pretty much anything you want. With VoIP, we can even monitor down to VoIP jitter and lag times. So you can really get a good idea of how your VoIP network is doing. If you are remotely monitoring it, as many of us are doing now, we've been working on new ways to sort of monitor things like Zoom or Teams, working on new integrations there. We do have up-down monitoring for those as well as service level, but we don't have the full view that we would with on-premise VoIP. But if you are, in an office or a call center and you want to monitor VoIP, you can pretty much get all the information you want about it onto WUG there, as I said, down to jitter.
Very nice. A lot of flexibility. And then kind of what's the licensing model for WhatsUp Gold?
Yep, it's device-based. So I believe it starts at 100 devices, but there's a free version for less than that as well. So each point on the license is one device. So it doesn't matter how many monitors you add to that device. We don't care. If you want 1,000 devices with 100 monitors each, you don't need a 100,000 point license. You just do it with a 1,000 point license.
Nice. Yeah, that's great because I know a lot of devices can have 100 interfaces or something like that, especially virtual interfaces. And I've seen products that license based on the interface. So
yeah,
that's
exactly.
Cool. That's device based. And then, what's the easiest way to get started with WhatsUp Gold? You mentioned there's a free version. Would people just go and download and install that to see how it works for themselves?
Yeah, my recommendation would be start with the free trial. It is on the site. It says a 7-day trial, but support team is pretty generous with extensions as well. So that's going to give you fully featured WUG with no limits on the monitors you're able to use and the modules you're able to use. So I would start there, and you can really get a good idea for it. There's also a demo on the site. If you're not interested in downloading a free trial, you can watch an on-demand demo, which it's sectioned off into different points. So if you want to know more about device roles or you want to know more about virtualization monitoring, you can kind of hone in on that and learn that on the website as well, which is whatsupgold.com.
Whatsupgold.com. Awesome. And it looks like that's all we have here for our Q&A, but really great presentation, Jeff. Thank you so much. Thanks for being on.
Thank you. Thanks, everyone.
For more information, as Jeff said, visit whatsupgold.com, and you can download the free trial for yourself. Also, check out in the handouts tab there. There's a link to download the free trial. That'll take you directly to the free trial download page. There's like 6 quick questions there, and then you can download the free trial of WhatsUp Gold and get started monitoring all of your enterprise, applications, network interfaces, even voice over IP. So a lot of cool stuff. Again, thank you to Progress for supporting today's event, and thank you to everyone out there in the audience for sticking with us. It's now time for that next prize drawing. We have another Amazon $500 gift card. It's going to Deborah Weinstein from Maryland. Congratulations, Deborah from Maryland. Still one more gift card to give out on today's event, so make sure that you stay tuned for that. And now it's time for our next presenter on today's EcoCast. I'm excited to introduce Krish from Nutanix. Krish is the Director of Product Marketing. Great to have you on, Krish. Take it away.
Thank you for joining this webcast. So today I'd like to talk to you about why you need to take the journey to the enterprise cloud and how you can accomplish that journey. So first, I want to highlight what's top of mind for CIOs and CEOs today. There's a lot of conversation around how CEOs are paving the way for digital innovation to augment customer experiences, use digital avenues to create new opportunities and such, as well as expanding their organization's addressable markets. Now, all of this begins to fall back to the technology organization that's looked upon to unlock these opportunities, digitize processes, create new avenues that customers can interact with companies, be it through web tools or smartphone applications and such. So all of this puts a lot of demand and pressure on IT organizations. Now, given these tall demands, it's a lot easier said than done, right? Because we are still operating infrastructure like we have over the last couple of decades. We've got these various silos within the organization that require us to work with multiple vendors to acquire infrastructure, software that sits upon the infrastructure. And once we've done that, painstakingly put it together and integrate it such that it works seamlessly when in production, and when deployed, manage this infrastructure across specialist teams, namely for server, virtualization, networking, and storage and such. And when problems happen, come together in a room to troubleshoot what the problem is, and half the time devolve into blaming other teams for being the root cause for that particular problem. None of these scenarios are enjoyable, right? And it only gets worse when you need to roll out upgrades to various elements of the infrastructure stack, be it the BIOS or the virtualization layer, whatnot, right? That might disrupt the performance of the entire stack and have incompatibilities with other layers of the stack. And before you know it, 3 to 5 years from now, it's time to do it all over again. It is no surprise that this operating model forces us as members of the infrastructure and operations teams to focus on the speeds and feeds. We focus over 80% of our time just upon the infrastructure, when our stakeholders within the business or outside our customers and partners really care only about the 20%, the applications that run upon the infrastructure and that are consumed by them to get their jobs done or consume the services that the company is providing. They have no appreciation for what's under the water level. But we as members of the IT infrastructure and operations teams understand that for those applications to perform 24/7 seamlessly every single second of the day for our customers and for our business partners, you need a solid bedrock that's built upon the infrastructure. So quite often what we do, the role we play is that of an unsung hero, right? So, and this has been apparent based upon a survey we just conducted across a global audience of IT leaders when asked whether application developers collaborated with them when they needed IT infrastructure. 57% of them said that application developers consistently circumvent IT because IT is perceived as an inhibitor to innovation as opposed to one that fosters innovation. Now, we as members of the IT infrastructure and operations teams are smart, right? We understand that what forces us to stay in the speeds and feeds is the infrastructure itself. So one very viable option is make infrastructure someone else's problem, right? Enter the public cloud. So by doing so, you've basically outsourced infrastructure to a third-party organization, namely the public cloud vendor, and you're able to immediately offer those benefits to your stakeholders, right? They're able to deploy applications. Now there's this perception of less management. You get to pay only by use, so you don't have to commit budgets for a 3 to 5 year cycle. And finally, the infrastructure just keeps getting better and better with the continuous updates that are being pushed and deployed by the cloud vendor. But what we found is applications are beginning to return on premises within the data centers. Based on a survey we've conducted, we found that respondents said that they were 35% consistently over budget with their public cloud spending. And 80% of those respondents are moving over 50% of their applications back on premises. And this trend is not slowing down. It was 81% last year, and it's trending at 85% in 2019. So what's truly needed is this harmonious balance between public cloud and private cloud, where you've got workloads and initiatives that are best suited for public cloud, that are targeted towards your public cloud deployments. And for those more predictable enterprise-grade, business-critical applications that require performance control, the best place to land those applications is in the private cloud environment. And that is where we help customers get those public cloud benefits within the constructs of their private data centers. And we do that by delivering software-driven hyperconverged infrastructure that can be deployed upon infrastructure platforms of our customers' choices, and also enable customers to choose the virtualization layer that they would prefer based upon current skill sets or the natures of the workloads that are being run upon them. So this enables our customers to not just harness the benefits of public cloud within their private data centers, but also choose how they create their cloud experiences within their own data centers. So that is the dual benefit of choosing to use software-defined hyperconverged infrastructure to do that. And you'll find that, based upon the survey that I referred to previously, IT leaders across the world subscribe to this point of view. They want to land about 36% of their workloads on hybrid cloud, a significant number in private cloud, and about a quarter of those workloads within the public cloud. Now, this, while it might seem like a very harmonious solution, it causes other challenges where you've created silos between your environments where they previously existed between layers of the infrastructure. The applications and data are not portable across public, private, and distributed edges. There is different management methodologies across private, public, and distributed edge. So typically, you would find that you have the chief Amazon officer or the chief Azure officer, the CIO that continues to control the private cloud, and this emerging title that we've seen at some of the larger organizations called the chief digital officer that tends to manage more of these IoT and forward-thinking initiatives that address these distributed edge use cases. What's truly needed is to create one fabric of infrastructure that spans across these disparate environments, along with a shared pool of data that can be leveraged irrespective of where the applications need to land or who is building or delivering these applications, and upon which a shared set of services are constantly available to the innovators in your organization so they can very quickly deliver results with their innovations, right? So this is where IT has an opportunity to change the perception of being inhibitors to innovation to one that fosters innovation by really delivering that platform that fosters innovation to the multiple stakeholders within the organization, irrespective of whether they sit at HQ or are building edge applications or IoT applications in Timbuktu, for example, right? So this is where Nutanix has set its vision, to be able to deliver that enterprise cloud platform that is easy to manage and control from one single user interface across these disparate environments, so as to enable IT to deliver against business requirements as opposed to manage the speeds and feeds and the underlying complexity of these infrastructure deployments. So how did we go about doing that? First, the public cloud has done a lot of this at scale, right? So to begin, what we did is we took a good look at what best practices were put in place to enable public cloud architectures, right? And those included by making sure that there were no single points of failure, that it ran on off-the-shelf hardware, that it incorporated self-healing systems that enable the infrastructure to run at scale without an army of IT specialists to manage it, and pervasively adopt machine learning automation capabilities that were able to observe infrastructure performance and take action when possible to ensure that the environment was running without disruption and the applications are running at top performance. And to do this, when you do this well, you get all those public cloud benefits. The rapid time to market, the ability to pay as you grow, so you can start really small and scale out as your needs and your demands grow, and to be able to capitalize upon one-click operations that enable you to do complex operations with a single click. So what does this look like when you look under the covers? So what we've effectively done with hyperconverged infrastructure delivered by Nutanix is take what you see on the left, the traditional architectures where you've got the compute farms, the storage networks that connect up to the various SANs through the storage controller, the virtualization layer that sits on top of that, finally allowing the applications to be run upon this infrastructure. So we've taken the complexity you see on the left and reduced it to a turnkey software-defined computing platform, right, which is delivered by Nutanix AOS. And what makes this really unique is that you can start small and scale out as your needs grow, non-disruptively. And it also allows you to use the virtualization layer that you would prefer to use on top of Nutanix, or enables you to use the built-in virtualization capabilities, namely AHV, that is delivered by Nutanix. When you go to public cloud, the last question you ask is what the virtualization layer is, and we believe that this should be the experience that you enjoy when you are using a hyperconverged infrastructure-powered private cloud within your own data centers. And what makes this increasingly attractive is that it works with your existing rack configuration and your top of rack switches as well. Now, how did we get this done? So looking under the covers, right, here is what a traditional virtualized environment looks like. You've got your server farms, your hypervisors, your VMs that run on top of it, storage networks and the SANs. So with converging storage solutions, with HCI, what we've done is we've eliminated the need for those SANs and added storage into the nodes that sit within the compute farms, right? And you can choose a variety of storage technologies, be it flash, NVMe, or spinning disks that sit with all these nodes. And once that's done, you virtualize the storage controllers. So in effect, what you've got is one distributed storage pool that spans across the nodes within your cluster that enables you to start small and scale out without limits. Performance only gets better as you scale out. And you can begin to imbibe some of those public cloud practices, which enables you to convert capital expenses to operating expenses by starting based on exactly what you need and using demand and new application workloads as reasons to scale out that environment over time. Secondly, it's got a lot of storage smarts built into the software that enable you to keep data local to those workloads. For example, if you've got an application running on node 1, the data associated with that application is kept in node 1. So what you've done is you've eliminated hops that would otherwise have existed on the storage network, and as a result, you enjoy increased IOPS. Finally, there is no notion of refresh in this mode of operation. You can mix different node types from different hardware generations within a single cluster, and that enables you to continue to add new technologies while still getting the benefits of older technologies that run within this hyperconverged infrastructure-based cluster. Now, the storage capabilities are advanced and meet all of those requirements that enterprises have, right from being able to very smartly tier data between various temperatures of storage that you might have in the node. If data is more hotly accessed, it's kept in the hot tier, namely flash, and if it finds that it is accessed less frequently, it will move the data to spinning disks if you have a hybrid storage environment. Secondly, it has native compression capabilities, deduplication capabilities to give you greater economies on how you use your storage. And finally, it's got RF2, RF3, and erasure coding built into the software that enable you to make sure that you are protected from any data losses. So every time there is data written to a specific node, it keeps copies of that in other nodes as well. So if that node were to go down, or if that disk gets corrupt, those blocks are recreated and data is preserved. It also has you protected from a DER perspective, from a disaster recovery specifically, that's perspective, right? Where it has native capabilities to help you synchronize across environments. So in the case of a failure, you can seamlessly fail over to a secondary site and fail back when your primary site is back up and running. It also has advanced security capabilities by being able to automatically check for security compliances and bring it back to the state, bring it back to compliance as well, right? So, it augments that further by being able to ensure that data at rest is encrypted. So it has support for both software, self-encrypting drives, or enables you to use software-defined encryption capabilities along with local key management. Now, in effect, you've been able to, with this, it's not just about consolidating infrastructure, but it's about consolidating operations as well. So with Nutanix hyperconverged infrastructure, what you're able to do is exactly that. You've got one single pane of glass that's delivered through Prism that enables you to very quickly acquire new infrastructure as and when you need it, as your environments need to grow, and add them to your clusters, which is then auto-discovered, and the resources automatically added to the pool, right, both for compute and storage. And when it comes to managing your infrastructure, it gives you end-to-end visibility across your infrastructure, right from the compute, storage, and the virtualization layers, along with the ability to detect anomalies when performance is being impacted. Or if you're looking to optimize your environment by eliminating idle VMs or often VMs, or managing QoS for VMs, bully VMs, or under-provisioned VMs. And fourthly, and almost as importantly, is that it enables you to do one-click upgrades across the infrastructure stack. Those painful processes that go into studying compatibility matrices and ensuring that you've created a right dependency map for upgrades across the infrastructure stack, whether it's at the firmware level or the hypervisor level, you're able to reduce all that into a one-click process right from within Prism. With Prism, you can orchestrate upgrades right from the BIOS up to the hypervisor and any other Nutanix software you have in place with one click. And Nutanix understands the dependencies across all these elements in the infrastructure stack and is able to orchestrate the right order of upgrades for you. Then finally, we spoke about scale, where you can continue to understand the runway of your environment based upon past behavior. So you will be able to get real-time visibility into when you will run out of resources and what you need to do, and in terms of acquiring new infrastructure and software to be able to plan for growth or to add additional workloads to your environment. Now, this is something we've all been proud of, and our customers enjoy the simplicity and the ease of use that hyperconverged infrastructure has been able to deliver within their environments. Here are examples of customers. The first one doing an upgrade from a helicopter using a smartphone, and the second one is another customer doing an update from his Tesla, and the third one is just a Nutanix fan who has a lot of Nutanix swag, right? So I thought that was a fun picture to add in there. So Nutanix has a lot of versatility, right? So it's not a point solution for any specific workload. What it enables you to do is to really achieve that enterprise cloud platform that you need to run a variety of workloads, address a variety of use cases within your organization, right from being able to run those enterprise applications or deploy VDI environments built upon Citrix or VMware, or consolidate infrastructure management and operations across multiple sites, including data centers and remote and branch offices, to be able to deliver collaboration and unified communication solutions for your workforce, to address the needs of developers by giving them cloud-native stacks or developer clouds that they can innovate upon and eventually deliver into production upon a Nutanix-powered enterprise cloud environment, to be able to run big data workloads, to exploit large, massive, vast amounts of data and gain intelligence to make better business decisions, and to rely upon the platform to run those mission-critical workloads built upon SAP and Oracle, which have to be resilient and performant 24/7 to keep the business running. And of course, to be able to do all this while you have the power to choose which hardware platforms you want to run the hyperconverged infrastructure software upon, and which virtualization layer you want to put into place based upon skills that you have and the applications that you want to run within your environment. Nutanix has been recognized as the undisputed leader in this area, specifically for hyperconverged infrastructure, by leading analyst firms, namely Gartner, Forrester, and as the leader from a market share perspective by IDC. We also did a TCO study. We commissioned a study with IDC to understand what the implications were of adopting hyperconverged infrastructure by Nutanix. And we found over a reasonable sample of our enterprise customers that they were able to reduce total cost of ownership by over 60%. They had 97% fewer unplanned outages, 3-digit ROI over 5 years, were able to pay back the investments on Nutanix within 7 months, and really be able to contribute to additional streams of revenue within the first year. And you get to do all this while you're partnered with the industry's best support organization. We're spread across 100 countries, have multiple worldwide support centers, and the person who picks up the phone when you have a support case is the one that solves it for you. So all our support engineers are highly trained, have deep experiences and certifications in virtualization and infrastructure technologies, and are in a position to handle a vast variety of issues that you may experience with and outside of your Nutanix environment. And this is what has given us a 90+% NPS score, which is an indicator to whether a customer would recommend Nutanix to his or her friend or colleague. And it is the highest NPS score that we have in the hyperconverged infrastructure space today. So with that, I'd like to thank you for your time, and if you have any questions, please ask away. Thank you.
All right, great presentation. Thank you so much, Krish. I've just brought up the poll question for everyone out there in the audience. What additional information would you like about the Nutanix solution? We've got a number of questions here coming in for Krish. I will be routing those over to Krish to answer electronically for you. So thank you so much for those questions. Due to time, we didn't have time for a live Q&A session with Krish. But again, great presentation. I want to call out the Nutanix URL that's there in your audience console. that will take you to the Nutanix One Platform test drive, where you can sign up with just an email address. You can gain access to the complete Nutanix solution in a virtual kind of lab environment, if you will, in your web browser. So it's a really cool, completely free option to learn more about Nutanix and to try it out for yourself. It's one of those, seeing is believing kind of things. They've had great popularity around their test drive solution, this free cloud lab offering. So make sure that you check out the Nutanix One Platform test drive. And of course, we appreciate everyone answering or responding to that poll question there in the handout or in the slides window. So I'll give you another few seconds here to respond to that poll. All right, thank you so much, everyone, for responding to the poll question there on the screen. It's now time for our next presenter on the EcoCast. I'm excited to introduce Mr. Mark Pena, Lead Security Solutions Engineer at Rapid7. Mark, are you there?
Okay, I should be coming in okay now. Can you hear me?
Much better. Yes, sir. We hear you, Mark.
Okay, sorry about that. There was some feedback or whatever.
No worries. Going great. Good to have you on. Take it away.
So once again, my name is Mark Pena. I'm the Lead Security Solutions Engineer here at Rapid7, mostly handling our public sector division, so public sector, government entities, higher education, so on and so forth. And we're obviously here to talk about monitoring and optimizing an IT environment, applications, cloud security, all from Rapid7 here. So what we're seeing a lot out in the world today from our customers, from our prospects, from everybody that we're talking to is a lot of organizations are being asked to do more with less. So more in securing things such as visibility into remote workers, software as a service, cloud solutions, tracking ephemeral assets such as like VM infrastructure, assets as they connect to the wire, what's on the wire, what's in our network, new technologies such as containers, cloud infrastructures, image pipelines, modern web applications, serverless infrastructures. So doing all this is no easy task. Prior to being a Rapid7 engineer, I was also a practitioner on the retail side of the house doing architecture, administrative, analyst, and I'm forgetting one of them, but it's 4 hats at once basically. So, once again, asked to do a lot more with a lot less. We know that cybersecurity is typically in that reverse sort of hiring situation where there's more open job recs than there are people to fill them. So how do we combat all of this? With less, we're seeing smaller budgets, especially now that we're living in the age of COVID, where a lot of people are potentially, not doing what they want to do. We have fewer headcounts, more to do, can't spend time with 15 different tools. So, we're seeing a lot of portal fatigue as well as just general problems getting everything up and running and configured and then monitoring it all from there. So how do we do all this? So Rapid7 has been working really hard on the Insight platform. So if you're not familiar with Rapid7, Rapid7 was founded in 2000 as a vulnerability management solution company. So from there, Nexpose was our sort of bread and butter solution. That's going to be vulnerability management from the network perspective. So from there, 2008, we acquired what's called the Metasploit project. If you're not familiar with the Metasploit project, it's pretty much known as the #1 penetration testing tool in the world. It's effectively a tool that every hacker, every penetration tester, every security personnel probably has in this toolkit. From there, we have really built upon what we're doing as a security company. So Rapid7, not only are we doing vulnerability management, doing penetration testing to give you that visibility into your network infrastructure, your web application security stack. We've also acquired some other companies and brought those into the platform. So Divvy Cloud is our latest acquisition for cloud security. A few years after we acquired the Metasploit project, we built a tool called User Insight. And what it was really meant to do was to provide that sort of layer of visibility into a SIEM, but not necessarily be a SIEM. So we found a lot of success in what we called user behavior analytics, built that into our User Insight solution, but we found that there wasn't really a line item in most people's budgets for strictly UBA. So we sort of went back to the drawing board on that and acquired a log company, a log aggregation company, put that as the powered backend for our user behavioral analytics tool, and created what's now called Insight IDR, which is our detection and response solution. So it's going to be what we consider next generation SIEM with user behavioral analytics, attacker behavior analytics, and some endpoint detection capability and response directly in that platform. And then finally, we also have our orchestration and automation solution, Insight Connect. So this is really meant to give you, the customer, or you, the security person, the capability to tying your best of breed solutions together to create that automation, orchestration, and response. All riding underneath that is going to be the Rapid7 unified agent. So throughout the platform here, from vulnerability management to incident detection and response, this Rapid7 unified agent is doing the vulnerability assessment. So with this, we're able to do continuous vulnerability assessment from those assets, regardless of how they're connected. So the real benefit in this is that this agent was built to be that remote sort of connection. So it was built with, I shouldn't say code in mind, but it's definitely COVID proof, in that as we see a lot of organizations transition to this remote workforce, we started to see kinks in the armor, if you will. So those assets that are typically in the environment and being vulnerability scanned, we're just not being vulnerability scanned anymore because everyone was working from home. So this agent was giving the organization that capability to get that continuous vulnerability assessment on those assets regardless of where they're at. So because it connects directly to this Insight platform, which is hosted in Amazon's AWS environment, any machine that is remote that has that connection to the Insight platform has that capability to do continuous vulnerability assessment. So that's on one side of it in vulnerability management. On the other side, in our incident detection response solution, we're giving you that capability to do the remote response to those assets should the need arise to quarantine a process, deprovision a user, quarantine an asset directly from the network. So this one agent gives you that visibility across the majority of the Rapid7 tools. So move to the next slide here. So I've already briefly introduced what Insight VM is. So this is going to be our vulnerability management solution. Insight VM, it's going to be sort of a hybrid solution. It's mostly going to be on-prem to facilitate that traditional network scanning, but there will be some cloud elements to the platform. Once again, that agent connecting directly to the cloud backend there to give you that consistent visibility on those assets, as well as the capability to drill into what we call remediation dashboards, remediation analytics, and these dashboard cards here are all going to be populated in that AWS platform so that they're not leveraging any sort of computing power or resource power directly in your environment there. So with this platform, you'll be able to assess new cloud assets immediately through AWS or Azure. You'll be able to get an accurate license count for those ephemeral assets. So things like what we call dynamic connections, or we can tap directly into those infrastructures that grant access to the network. So ESX, DHCP, Active Directory, we can consume directly from those, populate those to the tool without having to go out and get a network discovery scan on it. Cloud configuration, so find leaky S3 buckets or bad AWS firewall rules with that cloud configuration. We also have container image risk directly in the platform. Once again, with the Insight platform, everything is at this one license cost. Nothing in that platform is modularized. So everything that we talk about when we talk about Insight VM is included in that license cost. So the biggest approach that we're taking with vulnerability management is risk-based prioritization. So what this means in a nutshell is that instead of taking the approach of saying, I want to solve all 10s and then all 9s and then all 8s, we take the approach of saying, okay, well, this asset is something that quote unquote keeps the lights on. So we really want to prioritize this over something like a network, I'm sorry, not a network firewall, those are important, something like a network printer or an IP phone, where as we solve those 10s on domain controllers, but then we pivot to those 10s on IP phones and printers, we still have 9s on those critical infrastructures. We really want to prioritize that. So the approach that Rapid7 is taking to risk management and risk approach is that each vulnerability gets a score of 1 to 1,000. It's based on an algorithm of what is the CVSS score. We know that typical CVSS scores don't change over time. However, as a vulnerability ages, we typically find easier ways to exploit that vulnerability through tools like Metasploit or malware or exploitdb.com that people host exploits that they've created, and the numerical value is then kind of given to what is a critical mean here versus what is a critical mean there. So that's sort of what that risk-based prioritization really is. It's a way to prioritize assets that are important to you and then take a risk-based approach to say, what can I do that's going to net me the most amount of risk reduction for the least amount of steps? So it's a very interesting, very easy way to sort of facilitate that risk and make sure that you're getting it knocked out. Moving on to Inside IDR, this is our one of our newest solutions. I shouldn't say newest. It's one of the solutions that's doing very well because Rapid7 once again knows what it takes to stand up a SIEM. Standing up a SIEM, if anyone's never done it before, can be very, very difficult. There's a lot of tuning and rewriting rules and just building the platform up. When I say the platform of SIEM in general, building that from scratch can take anywhere from 6 to 8 months to maybe even over a year if you even have the right personnel to do it. So Rapid7 came in and did this and said, you know what, we have a lot of information that we're getting from the Metasploit project. We know how hackers and penetration testers are using these network-based tools. But we also have all this knowledge from the incident response that we do, from the red teaming that we do, from the blue teaming that we do. So we built a lot of what we call pre-detections as user behavior analytics and put those into this platform as predefined rules. So Inside IDR comes with, I think, around 70 predefined user behavior analytics. And these are the types of detections that you would build in a SIEM as you stand up that SIEM. So we really excel with this because all we're really doing with this particular SIEM is attaching your sources to it and then making sense of that data for you with these pre-built detections. As the platform has progressed, we've also introduced what's called attacker behavior analytics. So once again, the intel that Rapid7 has in the red teaming we do, the blue teaming we do, the vulnerability research that we do, all that is then brought back into this tool is now attacker behavior analytics. As we monitor those endpoints, we can see when child processes start from something else or if protocol poisoning is happening directly on that endpoint. And once again, we can leverage that agent to do that response for us. So with Inside IDR, you're getting that visibility into those remote workers, even if they're not on the VPN. Because that agent is running directly on the endpoint, we can see everything happening on that agent that's associated with the organization. So this platform is also cloud hosted, licensed by assets. So you're getting a predictable cost year over year and not skipping out on potential logs to send for storage and analytics. With traditional SIEMs, because they're typically priced on data that you're sending to that organization, a lot of customers will say, I'm just not going to opt in for local logs because it's going to potentially double my costs. With this licensing platform, we say anything that's a server, desktop, laptop that's part of your Active Directory, we're going to automatically associate that with the platform and it's licensed by that. So once again, because this is cloud and SaaS coverage, we have things like API integrations cloud to cloud with some enterprise cloud services like Okta, O365, Google, Box, Salesforce, Zoom. A lot of organizations are using these and then leveraging these to correlate back to those users. So once again, user behavioral analytics is really what's going to power this solution so we can catch those attackers and pull them out in real time. Pre-configured rules, like I said, these are going to be predefined with the platform, so you're going to spend less time building these out and more time responding to these incidents as they come up and actually hunting for the quote-unquote evil in the environment. DivvyCloud is our latest acquisition. This is a cloud security posture management. So with this, we can do unified cloud security for multiple platforms without having to rewrite a bunch of rules. So pre-made configurations for AWS, Azure, GCP, Alibaba, Kubernetes, so on and so forth. With that, there's going to be automated remediation in the platform, as well as some custom automation for Slack bots in the future. So brand new to it, so I don't have a ton to say about it just yet, but if cloud security posture is something that you're looking at, definitely hit us up. We can get a demo for you going on it. Finally, inside AppSec is going to be our dynamic web application scanning tool. So once again, Rapid7 has always taken the sort of hacker mindset approach to the way that we do vulnerability management, penetration testing, remediation response, so on and so forth. So with inside AppSec, we take the approach of a dynamic application scanning tool. So this scanning tool has what we call a universal translator. So we're going to be able to cover all kinds of modern JavaScript frameworks, APIs, single-page applications. We'll be able to do complex authentication methods, whether or not we have to do something like a multi-factor or a CAPTCHA or human interaction is required on that. And this platform is really developed in mind to give visibility from all three perspectives of application security. So that's going to be your security team, your operations team, and your dev team. So with that, you'll be able to automate these scans, dynamically scan these, get authenticated to these, get a deep dive into it, regardless of what that authentication measure or application looks like, and then have that single portal where everybody that has stake in that application can dive into it, look at the vulnerabilities, and then replay those attacks in real time to validate whether or not this is a false positive or a true positive. And then from there, we can determine, yes, I see where the SQL injection was here. As a dev, I've gone and redid my code, I've sanitized it, and I've pushed it to a test server. We can then use that replay functionality to test that very same attack against that new update and say, you know what, this works. I can now mark this as completed and move along with my day here. So once again, really trying to give a platform that everybody is going to be able to work out of that has stake in those web applications. Insight Connect is, once again, our automation and response solution, or orchestration, automation, and response solution. So this is going to be able to give you that capability of having, once again, best-of-breed solutions and being able to build those automations without having to have any kind of coding involved. Rapid7 maintains what we call the extensions and the, I'm losing my keyword here, using oh man, I can't believe I'm just completely brain dead here. However, with those tasks, we pull from what's called the extensions library, where we have these integrations. We can build the integrations for you as a Rapid7 customer if a integration does not exist with that, as long as the API is there for us to build that. That's something that Rapid7 builds for you, so that once again, you don't have to have any sort of custom coding experience in order to build out these integrations. We build these out into automations for you, and you'll be able to pull from a library of these to make everything funnel through your Slack or your Microsoft Teams instead of email. Also, with the acquisition of this Insight Connect, some of those native automations have been brought to our tools, such as Insight VM and Insight IDR, without having to be an Insight Connect customer. So some of the things that our customers say, you know what, it'd be great if we could automate this directly from the platform, we've brought those native to the other Insight programs or Insight platforms there. But if you need something much more granular as opposed to an out-of-the-box automation integration, this is going to be where Insight Connect would come in. So we see a lot of customers using this to automate phishing responses, where an employee might get what looks like a phishing response, and they can send that to a phishing inbox where the automation is done. It strips the email, it strips the link, tests it, it looks for any potential malware that's associated with that, and then can either classify it as a false positive or classify it as a true positive, and then set firewall rules into play from there. So a lot of customers are using this to also, like I said, integrate with their Slack to say, here is something that automated. Do you want to respond to this from Slack directly, or Microsoft Teams in this case? But coming up on time here, I'd like to leave a little bit of time. I do have a hard stop at the top of the hour, but if anything looks cool to you guys, feel free to hit up the rapid7.com website when you can set up for a self-automated trial. Or if anything looks good that you might want to dive deeper into it, we can always pair you with an account exec and then do a live demo from there.
Awesome presentation, Mark. Really cool stuff. We do have some questions here for you from the audience. I want to remind everyone that the Rapid Insight trial is over there at rapid7.com, and the Rapid Insight demo as well. Before I advance here from that slide and move on to the poll just says, what additional information would you like about the Rapid7 solution? And if you have a question, for Mark. Now is the time to get it in. So let's see. First question that I wanted to ask you, Mark, is they're saying, we know that apps are a growing concern for folks. How should CISOs and practitioners be thinking about application security? Any recommendations for quick wins that could be implemented?
Yeah, that's something that we come across a lot, especially customers that are sort of new to the application security. The best advice we can typically give there is, just like we've approached in the Inside AppSec tool, is let's break down those silos, let's work together as a team and start moving more to the left in the development of the application itself. As we see those nightly builds go out, we can automate the tool to automatically scan those nightly builds, report back to the dev so that we're fixing problems in dev and test as opposed to pricier fixes that might happen as they roll out to production.
Excellent. Yeah, good tip. Let's see. Next question. Monitoring and optimizing your IT environment. When it comes to that, apps in the cloud, it's no small task. Any advice to practitioners out there when it comes to prioritizing and identifying the right partners and solutions to fill security gaps? I know that's kind of an open-ended, high-level question, but any suggestions?
Yeah. What I really like about what we've done here is as this full vendor that can do the full spectrum of security, that gives our customers one throat to choke, right? They're not saying, I need this solution to talk to this solution, and you're only part of half the problem here. I need you to work with this other company in order to make this work right for me, if that makes any sense at all. So what I would say is, whether it's Rapid7 or not, finding a good partner is going to be somebody who is, knowledgeable in all that entire spectrum of security, that is able to give you that honest opinion to say, I'm not trying to sell you a firewall. I'm telling you the environment that you've got today, these solutions would work best because you're already using X, Y, Z. Does that make sense?
Yeah, absolutely. I like the one back to pat, one throat to choke kind of analogy there with when it comes to security tools, because you could literally implement tens or many more security tools in an infrastructure and just make it overly complex so that it's just not functional anymore. So reducing the number and having a single company to go to, I think, is really smart. Next question: can you deploy the Inside Agent remotely?
So yes and no. Depending on the way that your assets are set up, the Inside Agent, because it connects directly to the Insight platform, yes, it can be installed wherever you're at, and it's automatically going to make a connection to the Insight platform. From there, because of the way that it monitors the asset and itself, it has that administrative privileges on the asset to do self-updating. So absolutely, yes, it can be deployed wherever you're at and however you're doing it, but it can also be deployed like GPO, SCCM, individual install. So it's very simple to get up and running. It's an MSI file at the end of the day, so a lot of different ways to push that out.
Excellent. Yeah, that's good to know. Fast deployment is very important, of course. All right. Well, it looks like that's all the time we have for questions, Mark, but it's been great having you on. Thank you so much. Thanks for having me. And thank you to Rapid7 for supporting today's event. Of course, go over to rapid7.com and you can try out the Rapid Insight demo as well as the Rapid Insight trial for free for 30 days. So make sure that you check that out. Also, check out the handouts tab there, and you'll find a PDF that you can download, which is the Application Security Buyer's Guide, 15 questions to ask yourself and your security vendor. So make sure that you download that before you go. And now it's time for our final Amazon $500 gift card drawing. This gift card is going to Chris Smolin from Tennessee. Congratulations, Chris Smolin from Tennessee. And then earlier, Deborah Weinstein from Maryland and Peter Crisano from Massachusetts. Congrats to all the prize winners. Before you go, don't forget to subscribe to the 10 on Tech podcast in the iTunes store. And if you're a potential sponsor of an upcoming event, reach out to us at connect@actualtechmedia.com, and we'd love to chat about having you on a future event. I hope that you'll join us on our next MegaCast. That's coming up on actually next week, Cloud Strategies and Solutions with Rubrik, Druva, Veeam, Nutanix, and OutSystems. Hope to see you there. Congrats to all the winners, and of course, thank you so much for everyone taking time out of your schedule to join us on the EcoCast today. I hope that you learned a lot, and have a great day. See you next time. Bye-bye.